It's very annoying. You're the only one who can see it, if that's any solace. Before
Oh,
we
that's
get
good.
started, just a logistical note for all of the participants. Please feel free to ask questions in the Q&A and to comment on other people's questions or upvote them if you have things to add there. Anything that's not strictly a question, please put it in the chat to all panelists and attendees. There are a few different options in the dropdown. But let's get going. Logan is pointing out that we're not on YouTube Live yet. So I think that's a question for Ranjan if he's still here.
Yeah, we are now on YouTube Live. I just started the live stream. Yeah, Logan, could you check and confirm? All right, we're definitely on the YouTube live stream because I can see the YouTube live stream.
Yep, we're all good. I'm hanging out there and just trying to remind people to ask their questions here in the Zoom Q&A.
Yeah.
Sweet.
And Jacob, the first question for you, slides and code are going into a GitHub repo?
Yeah, so I meant to, I don't know what the best way was to like share these. So I'm just gonna post them in the chat for now, and maybe I'll go and update my workshop description later with the links to them. But yeah, there's the repo here and then the slides here, and I'll try and combine them at some point.
Awesome.
All right, so we're ready to rock and roll here.
I think so.
Okay. All right, welcome everybody. My name is Jacob Quinn. I work for a company called Domo. We do business intelligence, dashboard building, but also a lot more in terms of data pipeline, data connecting from different web services and databases and ETL transformation stuff. Just kind of managing all of the data for your business in one place and getting value out of it. So that's kind of been my jam for the last several years. We love Julia because it's fast, it's data oriented, there's a lot of flexibility, it's really fast to prototype. We run in a cloud architecture, software as a service, and so we're built all around microservices. And so that was a key part of us being able to use Julia, was being able to set it up in a microservice kind of architecture for deployment. So a lot of the things that I've done in the Julia world, I've been around for a long time, since about 2012, working on different things. And it's all been kind of data related, and also in the last couple of years, microservice related. So building some of those parts out in the Julia ecosystem that we needed at Domo in order to deploy things. And so yeah, that's kind of a little bit my background, and kind of why I wanted to share this was, as I put in the workshop description, I think Julia is a really great language for building microservices. Like I mentioned, the ability to quickly prototype things and deploy things and see code run and interact interactively with things, like those are all like such great advantages. I mean, I compare that with like working in, say, Java, where it's compiled and there's all these other things. Yes, they already have like huge frameworks that are been out there for a long time, but the thing with microservices is there's general architectures, but you have to customize things so much that you can't always rely on just frameworks to do everything for you. You're always going to need to customize things. And so having that flexibility to prototype and iterate in a flexible language like Julia is a real big advantage. So anyway, today I'm going to talk through building microservices and applications in Julia. We're going to actually step through building an entire microservice, even to deploying, and hopefully that works. I ran into one issue last night and tried to push a fix this morning, so we'll see if that worked. Yeah, feel free to ask questions. So a big part of this is going to be cloning this repo. So I'll move to the next. Yeah, we'll get there. So I'm going to talk a little bit about microservices overall, but then I have a slide here where we're actually going to get started with the repo. So if you want to go clone that or dev it, you could do that now. But that's the repo we're going to be using. I've kind of made a bunch of Git branches that will step us through each step of the building process. But yeah, that's the repo. So if anybody has trouble getting that or seeing it or whatever, just let me know and we can figure that out. So let's talk about microservices. What is a microservice? It's really simple. It's just basically a program that is running in the background somewhere. So it runs continuously. It has some kind of API with usually like a REST API, which means it's an HTTP server that's listening for certain URLs to come through. And then the logic of the program is doing something based on the URLs that you're sending in. So if I go to google.com, there's actually a server somewhere in a data center listening, and it receives your request and says, oh, he searched for this term, so I'm going to go look up what websites I should send back to him, and then it sends back a response. So request comes in, I send a response back, and the logic in between is kind of the business logic, if you will, of your microservice. So I listed some examples here. You could track your music album collection, or you could log a sales invoice for a business. So we made a sale, so I'm going to input that somewhere. And a microservice is listening for those invoices to come in. You could store scientific experiment data. You could train a machine learning model, basically anything really. But these are some of the things that, just as examples. So it's really just a program that's running somewhere, and it's got a kind of defined API that's you can interact with it in some way. In terms of architecture, there's entire books and articles, blog posts out there. There's a lot of stuff out there, so I'm not going to go super deep into this. This is kind of my take on a very simplified idea of how you architect a microservice. So, and these are a little bit my own terms. Sorry if they're like confusing in some way, but these are kind of what people taught me over the years, and so they're kind of what I use. But there's a resource layer.
Hey,
So
Jacob,
that's
some people are
yeah.
having trouble reading the slides. Can we go into the full screen mode?
Oh yeah, is that this here? Present mode?
Yeah.
Okay. So there's a resource layer. So this is how do clients, users use or call your service? Is it through REST endpoints? Is it through some kind of remote procedural call interface? Is it TCP directly? Is it some other kind of thing? What kind of parameters or inputs are they passing? So are they passing JSON objects? Are they just passing strings or integers? Are they allowed to pass anything? So this is kind of the resource layer. So this is the client interaction, phase, and this is the kind of top layer of your service, if you will. The resource layer will take inputs from clients, from users, and pass them on to the service layer. The service layer is kind of your business layer, if you will. So it's validating inputs, checking authentication. It's saying, are we getting what we're expecting from users? Is there anything out of the ordinary? Is it wrong? And it'll do whatever service actions or calculations that are needed. So in the Google example, they're actually going to a big index. I don't know exactly how it works, but they're going to a big index somewhere saying, okay, for this given input of their query string, here's the set of 1 million websites that we're going to return to them. And so that's the logic that's performed in this service layer. And then we also often talk about a repository or mapper layer. And so this is where we're interfacing with persistent storage or devices somewhere that are a part of our service that we're using in our service to accomplish some function. Usually it's persistence. So I'm getting input, you searched for a query string on Google, and I'm actually going to save that off somewhere. I'm going to record that, hey, you searched for this thing on this date from this browser, from this country, IP address, whatever. I'm actually going to log that somewhere so that I can use it later, right? So I can come back and say, hey, you searched for this yesterday. Do you want to search for it again? And maybe I can speed up the response, with that query, things like that. So that's the repository mapper layer where, we're talking about logging, storing things for your service. So this is kind of deals with the persistent side of things, whereas your service layer is very ephemeral. It's kind of cold hard functions, right? It takes inputs, it produces outputs, but it's stateless. There's no, nothing that affects things from call to call. And then the other thing we often talk about is like model objects, and these are your types and your structs, and this is how the actual objects you're working with throughout your microservice. So as people call your service, they might be expected to pass in a JSON object with certain fields defined. And so you can model this in your microservice by defining your, in Julia, your struct that is expecting, these 3 fields. And those are used all over the place, right? So in the resource layer, we might expect those to come in from the user. And we also expect to pass them out, right? So what objects will the user get back out when they call your service? That's part of your model definition, your service definition. Your service layer is obviously working with those model objects, and then also your, persistence. A lot of the times, if you're working with a relational database, MySQL, Postgres, or a NoSQL database, there are certain formats expected that they can store things in. So, with a relational database, they have a 2D, usually a very normalized pattern of how they're storing data. And so you need to translate from your model object from a Julia struct to the persistence format. Sometimes there are, databases that can store an arbitrary whatever serialization. So, maybe some of these NoSQL databases, you could just serialize a Julia object directly. But then you're also, could run into concerns there where you're relying on the Julia version that you serialized it with, things like that. And so sometimes it's to the advantage to translate it to a specific, long-term persistence format that you'd be able to serialize, deserialize, no matter, if your service layer evolves or changes or, has breaking changes, things like that. It's part of the reason that the CSV format continues to exist today, even though it's a horrible format. It's plain text, it's very straightforward, and people continue to use it because it's a very straightforward format. So that's a little bit your typical microservice architecture. Like I said, there's like entire books written out there in software engineering about how to do stuff like this. This is kind of my very high level thing that we're actually going to follow pretty closely as we build our microservice. But it's just kind of hitting the main components of a microservice and how it's typically laid out. So if we go through an example, this is actually going to like, related to the example we're going to be building out today in our microservice is tracking your music album collection. So we're going to track, I want a microservice where I can store the music albums that I listen to and retrieve them. And then I also want this really, helpful service function, which is pick an album to listen to. And I want some logic there where it's picking one that I haven't listened to recently. So this is going to be the microservice we'll build today because it's very illustrative of all these things. So in our resource layer, we're going to have our CRUD endpoints. So CRUD is a common term for create, retrieve, update, delete. So it's dealing with your usually your model objects directly. So my model object in this microservice is going to be an album. So it has a name, it has an artist, a year, it has a vector of strings that are going to be the songs, and then how many times it's been picked. And so the CRUD endpoints for my album are going to be create album, where the user or the client needs to provide the name, artist, year, and songs. We're going to provide a retrieve endpoint, so get album, given a ID, an album ID that gets generated. We're going to be able to return that as a JSON object. You can update your album, okay? So maybe you had a typo, you can fix the artist name or the year, or maybe you missed a song, so you can add the song. We can also delete it. So you can delete the album if you maybe lost it or broke it or don't want to listen to it anymore, whatever. So that's going to be our resource layer, is the CRUD endpoints for managing kind of our model object here, the album. But then we also have this kind of service logic endpoint, which is I want to be able to call an endpoint, make a URL, call request, pick an album to listen to, and then I'm going to be able to get back one of these albums. And the service is going to manage that logic in terms of which ones have been picked, and we're going to pick one that you haven't listened to recently and return that to you. So then those are the endpoints that clients can call, and then we're going to have the service layer. So that's where we're going to validate, hey, when you create an album, it needs to have a name, an artist, and a year. Those can't be empty, or the year, maybe it needs to be validated. We're only going to accept years between 1930 and 2020. And then the service layer is in charge of actually constructing the album object from these inputs from the user, and passing that on to the repository mapper layer to store, because we're actually going to store these albums for you. And then the service layer is also in charge of the logic of the pick album to listen to. So it's actually going to look through your albums. When you call this endpoint, it's going to look through your albums and how many times each one has been picked. It's going to filter to the ones that have, not been listened to recently, and it's going to randomly choose one to return. And then also log that, hey, this has been picked. So it's going to increment this number here. And then the repository layer, as we've talked about, this is just for storing things. So the things we need to store are the albums, the number of times they've been picked, that kind of stuff. So that's kind of the example we're going to walk through and kind of laid out in the architecture that I've showed. I'm going to check real quick on the Q&A here. Maybe I'm in full screen mode, so I can't do that. Yeah, okay. So we do have a question here. What is Julia memory print in comparison to other popular methods for? Okay. Good question. I'm actually going to save this for a little bit later. Okay, she marked it as live, so we can answer it live. That's fine. So Julia memory footprint it really comes down to the memory footprint of Julia in general, which is not super small. I mean, we're not talking Go language here for compiling like the most smallest executable possible that uses like minuscule service. Julia in general, there's a few different options in terms of compiling executables out there that are actively being developed, but typically you're going to be deploying the full Julia runtime with your microservice kind of application and running that. And so we kind of have a baseline of the Julia runtime itself, which, you know, I think it's a couple hundred megabytes in terms of RAM. But then it's really based on your microservice from there. So it's not the smallest footprint in the world. And I think there are efforts, though, to do that better. I know there's been active discussions, you know, among core developers around maybe providing a way to build Go-like executables where we say, this is our main application. I'm actually going to define like a C main function. And when I say compile that script or that module with this main function, it's going to strip out anything that's not needed and compile down to like you know, a core executable that could then be deployed, you know, with a smaller footprint. So I know there's active work going on there. So I think it'll get better over time, but as is right now, it can work pretty good. And we're going to talk through at the very end of the workshop using package compiler to you know, aid in deploying your microservice and kind of bundling it up so that it's very quick to start up, which can be important in situations like serverless or as I'm going to show you, Google Cloud Run, where you're deploying containers and they might get spun up and spun down really quickly, and you want it to be able to be very responsive. So we're going to talk through that. So good question. So we're going to move on now to the code. So rubber meets the road. We're going to build a microservice. So if you, here's the link to the repo. It's on my personal GitHub. It's called musicalbums.jl. So from the Julia REPL, you can do bracket, go into package mode, and then you can say dev in the URL. I've tried to put everything that's like runnable code in this kind of format throughout the presentation. So if you see this, this is something you can run somewhere. So this is from, you can run this from Julia, and it should install it in your like Julia dev, wherever that's set up. So I think it's typically here, but I think that is configurable. And then the first thing you're going to do is git checkout step 0. So I kind of have it set up with different branches, like I mentioned, so that if I am here in the repo, okay, I can say, when you clone it, you'll be on the master branch, but you can say git, I'll do the full thing, not use my shortcuts. I'll try and remember that. So I can say git checkout step 0, and then I'm going to be kind of this bare minimum, you know, setup. And then you can open the package directory in your favorite editor. I like to use VS Code. I'm going to close a bunch of these so that they're not in our way.
Jacob, could you zoom in on the font once you're ready to start going through code? It looks pretty small.
Yes, I will do that. Okay, it's good to hear. Let me move this out of the way just a little bit. Okay, and zoom in on the font. Let's see, window, zoom. No, I don't think that did what I wanted it to.
Command plus
Isn't
stop
it?
in just works.
Yeah, there we go. Is that
Good.
Tell me when. Is that good if I go right
I
there?
mean, I'm happy, but I also keep my fonts absurdly small. If anyone in the chat would like to weigh in on the font size, please do so.
I'll go one bigger. How about we'll stick with right here. Okay.
Well, it looks like people want like one more.
One more? Ooh,
One more.
okay.
Yeah.
All right, we're going big here. I'm gonna shrink this down a little bit then. Okay, so we are at step 0. Let's see here. We've opened the package in your favorite editor, hopefully. So in VS Code, what you do is you can go here to say add folder to workspace, and then you would navigate to the workspace. You would navigate in your file system, whatever, to where the repo just got dev'd, and then it shows up like this. So you have music albums over here in your thing, and you can open it up and see all the files that are in there. As you can see, I've kind of laid it out as kind of I outlined in the diagram here. So we have the top level package file, musicalbums.jl, and then we basically created a module for each of the different parts that we kind of talked about, each of the different architecture parts. So for example, we have a model module, and we're using the Julia syntax here where we are including the file, which means go get the code in this file and evaluate it within, in this scope. So wherever this include function is run. And then we're going to call using dot model, which means anything that is exported from that model, anything that's exported from that module will be brought into scope within this, where we're within this current scope that we're in. So we're going to say using that model, which means anything exported from model will be available to anything evaluated afterwards, which is nice because, as we said, when we define things in our model module, we're going to want to use those in the mapper and the service and the resource because it kind of affects everywhere. So notice the order here is kind of reverse from what clients call. So when I'm a client, I will call, and the first thing that I run into is the resource, which defines the API, which calls down to the service, which calls down the mapper, and all of these are using the model objects that we've defined. So that's kind of the order we've defined things in here. And notice that I included a client module as well. This isn't strictly necessary when you're building a microservice because you're building the microservice. You're not really building, you don't necessarily need to call yourself, but we'll see, and I'll show you a few different ways that this can be really helpful in terms of testing your microservice. And later on with package compiler, I'll show how it's really useful for generating the package compiled bundle that will be really fast because we'll have a way to exercise all of the code paths of our microservice that will then get precompiled in our system image. So that's why I like including a client module within the microservice itself. So I think that's all we wanted to talk about with step 0. So let me check the questions here. Looks like somebody asked the difference between using thing and using dot thing. So I walked through it a little bit, but the using dot thing means I'm going to try to use this. I'm going to load this module from the current scope, as opposed to if I were to type using model here, then the loading code in Julia will actually expect that to be a package somewhere, or in the, I think it's in the load path of, so if I'm here, there's like this thing called load path, right? So it's expecting it to be
way bigger on the terminal.
Oh, okay, good. Yeah, that's good to know. I'll make that bigger. Try to match what we have going on there.
Awesome.
So it's gonna, when it goes to load a package, it's gonna be expected to be somewhere in these, it's a standard lib or in the, current environment that you're in or wherever. If I say using dot module, that means actually go look for a module definition within the current scope. And we'll see later, there's actually a way to say using dot model, which means don't load this module from the current scope, but go to my parent module scope and find that module and bring it into my scope. So we're actually going to use those, and it's really, it makes it really nice in Julia because you can refer, as long as you define things in the right order, I can refer to these things however I need them, and they're just available. For people familiar with Java, This is actually super, super nice in Julia because you have a lot of heartache and frustration in Java because you have to work with beans, right? And you're always having to manage your beans because in Java you have a class object, but when we're talking about these kind of modules in Java, you only want a single instance of them. So you want a single instance of your class that gets loaded everywhere, right? So you want the same model instance, the same model module to be loaded by all the other modules. You don't want each, mapper and service and resource to have their own copy of the model module in their module, in their package. And so in Julia, it's nice because you kind of get that by default. Each module is kind of a bean in the Java sense. And when you load it, as long as you refer to it in the right scope, then you get the same copy of code from everywhere else. And not only from an efficiency standpoint, that'll be nice in terms of like revise where, if we're iteratively developing our microservice and we're reloading things with using revise, it's the same module that gets tracked and reloaded. So good question. Hopefully that answers the difference between using thing and using dot thing. What's the next question? Small question. I'm not used to the way that splitting stuff. Would it using include like that work with revise in the REPL? Would you include during development change to include when you want to use it in prod? I'm not sure I quite understand the question here. I guess I'm wondering if the question is like splitting things out into different files versus having it in like one big file.
I think the question is just, would revise work with this setup, or do you need to change those calls to include T?
Oh, wait, what's include T? I guess I'm not familiar with include T. Does somebody know what
revise's version of include for including scripts that you want to track with revise. I think to me, the answer to the question is revise works fine with regular include, as long as your package is set up with like a module and the Julia package.
Yes, yeah. So that's correct. So because we're wrapping all of this in a module here, you see we have this module music albums. And when I go to the Julia REPL and I say using music albums, it's loading this code and revise will track all of these includes. So yeah, this is revise friendly. If I change something in the model file, revise will pick up on that. So yeah, this is definitely revise friendly. So yeah, thanks. I think that was Logan that helped. So thanks for that. Probably not really, but speaking off of in the correct device and giving out ordering code to prevent issues with circular dependencies this introduces. This is a good question. Circular dependencies are a bit tricky in Julia, I know, because like we allow them with structs, like a struct can have a field that like references the type itself, that's okay. When you start trying to reference other types within each other, it definitely gets messy. I know that Keno proposed something at one point where he said, we could kind of like half initialize this struct, and then when like basically we would like initialize the struct and like put a placeholder there to say, look, this is expecting a type of this to be defined at some point before we use it. But if you tried to use it before, it would be like an undef ref error. So I actually don't remember where that conversation went, or if it's still like an open PR, an open issue, but yeah, I know there's some trickiness there. We've dealt with that with like the flat buffers file package, because so flat buffers is a kind of serialization format that Google developed that kind of is just a generic way to serialize objects in a format that has some advantages. It's a binary format, but it expects to be able to recursive or like circular reference define types and stuff. And so we ran into some issues with that with Julia. In terms of microservices and defining things here, hopefully we don't run into those things too much, because as I said, we're going to put all of our type definitions in our model module. And we're going to have that pretty early in our stack here so that all of these later modules will just have access to those. And so hopefully we won't run into those. We're going to add several more modules as we go through the microservice building or the microservice building today. And we're just going to think through, basically always want to put things as early in the stack as possible. So if it only relies on model, then I want to put it directly after model. Or if it requires model in the mapper, I'll try and put it, insert it there. But we always want to keep things as early in the stack as possible. But I know building out microservices, I have run into issues where it's like, oh, I kind of need to depend on this and I need to depend on that. And usually that's just a matter of there's maybe an abstraction I'm missing, right? So maybe there's something common, both these modules seem to depend on each other, but they also depend on this. So maybe I need to factor something out into its own module that I can load earlier that then both, the other modules can then, rely on. So yeah, it's always kind of a tricky business, but hopefully that helps. It looks like Tom is providing some answers as well. Thanks, Tom. Would it make sense to make the resource and service layers packages? Yeah, potentially. Personally, I'm a big fan of keeping things as minimal and inclusive and monolithic as possible, just because I feel like I've seen more issues when things get too spread out. But there certainly could be advantages if your service got so big and complex that you needed that, right? Because if you had your model definitions in its own package and you needed to version those things, and then if your service layer, your resource layer needed to version things, like that could be a good way to split things out. But typically when we're talking microservice, we're talking something that's very self-contained and as small as possible. So I think I don't know if more common, but another pattern would be maybe I need to split things out into a separate microservice. So basically I would copy this entire music albums package and I would create a separate microservice, maybe that dealt with different endpoints and different model objects and whatever, as opposed to maybe keeping too much in one microservice that it was getting too hard to manage. So that would be my thought on that. Won't using music albums model do the same thing? Yes, I think so. Yeah, I think that would do the same thing. This is just a convenience thing. So yeah, you definitely don't need to do the exporting if you don't want, if you feel like that's going to clutter things up or whatever. It's just a convenience thing. When I say using music albums, I like to then in the REPL just be able to reference like a model object or whatever. So yeah, that would do the same thing. Is there a pro-con for not putting a using mapper instead of doing it all at the top level? Oh, so I think they're saying like in the model, I would do like using mapper here. No, I don't think there's a big difference. I mean, if you prefer that, I think that'd be fine. I like to do it here just because in the module files, I kind of like to keep it, this is the start and end of the file, there's nothing else. Just in case I like forgot that or something. I like to think of the mapper file as only containing the module definition, if that makes sense. And so then anything else dealing with the mapper module would be at a higher level, like here in music albums. So that's kind of my preference, but it wouldn't be a big difference. He's saying using mapper inside the module. Yeah, I'm not sure I'm understanding the question there then, but maybe we'll get to it later. So yeah, hopefully we can answer that later. I'm going to talk a little bit about the dot dot later, so hopefully we get to that. Okay, so let's move on. So we're going to go to our repo here, and we're going to say git checkout step 1.
Hey, Jacob, could you make that font a lot bigger again?
Oh yeah, sorry. I have a couple different terminals here.
Okay.
So I made
My
one bigger
button.
and not the other. That looks like about the same size. So, okay. Okay, so now, and on each of the slides, I've tried to put it, I can probably even make this page bigger, right? If I go like this, oh yeah, maybe that'll help. I've tried to put the command for this slide up here in the top right. So it'll have a get checkout here on each slide. So you know, okay, for this slide, this is the state of the code I should be looking at. So in step 1, the first thing we're going to do is define our service contract. So what is the API? And I've tried to put in each of the slides as well a diff of the previous step to the current step. So feel free to open that and it'll take you here and you can see here's all the code that's been added in this step. So we're comparing the 2 branches here. Pay no attention to all of my typos and mess ups in all the commits here. What we're really interested in is the final diff here of what's been put in. I also like in VS Code, there's a handy little extension called GetLens where it will show you, oh, no, don't show me that. There's actually a way to compare branches. So if I compare here, I can actually type in step 1 with step 0, and then it'll show me the file. It'll show me basically that same diff that I can see in GitHub, but I can see it in my editor here. So I think that's kind of neat. I'll probably use that today to show and highlight some differences. But yeah, so let's go back to here. The first thing we're going to do for our microservice is we want to define the contract. So what is your service going to do? And let's kind of nail down some specifics there. So we're going to define the contract in 2 places, in the resource file and in the client file. In the resource file, that's going to be our service endpoints. So this is what our HTTP server at the very, core of it is going to be listening to. It's going to listen for certain URL, paths to come in. And then in the client file, we're actually going to define client functions that will call those endpoints. So let's look at resource first. So here we're using 2 packages right off the bat, HTTP and JSON3. I'm not going to talk a lot about the difference between JSON packages. I've answered that a few different times in other places, so you can go look that up in Discourse or I guess not Slack, but basically I wrote JSON3 and so I like to use it versus other JSON. But we're going to see one of the core things that JSON3 does provide is reading custom structs directly and very, very efficiently. So that's one of the big reasons we're using JSON3 versus plain JSON. And we're going to use HTTP for HTTP stuff. So in HTTP, also notice that I'm bringing in both the model and the service modules here. Let's talk about that real quick. So you notice we're doing the ... here. So what that means is in my resource module, I know that I'm going to want to use the model definitions of my microservice. And I know from our architecture diagram, right, that the resource, once it gets input from the client, is going to pass the request and the inputs onto the service layer. And so I know I'm going to be using the service module in my resource module. And so I'm importing both of these. And like I said before, when I have the ... that means one dot is look within the current scope, like whatever module I'm currently in for a module definition model or service and load that. If I say ... that means go above, oh, I can't edit in the read-only menu. That's okay, fine. Go above this module definition, go into my parents module and look for that definition, which is exactly what we want, right? So I'm in the resource module scope, But if I go to the parent of resource, which is music albums, we're going to find this model definition, this module defined within this scope. And that's what we're going to be importing into our resource. So this is just to help Julia code loading understand where to go to find these things in an efficient way, right? So it's going to understand, oh yeah, I know that there's a module, man, that's hard to say, in the parent scope of the resource module, and I'm going to load that into the resource. That is as opposed to if I were to like do an include in here that would like load its own copy of the model module in the resource file, which is what we don't want, right? We just want to load code once and then reuse it everywhere. So here's how we're defining our contract in the resource file. First, we're going to create a router object from HTTP. A router object is something where we can define for certain URL paths, we want certain request handlers to handle that path specifically. So let's look at this one specifically. We don't have a diff that we're changing from here, so I'm going to move this over so we can see all of this. So we're going to do http.@register. It's a macro because currently this is it's kind of a static thing. So you can only define routes kind of once at a top level, and then they're kind of fixed. So there's no dynamic route manipulation or addition currently with HTTP router. That's just kind of how it's built currently. And I can go into details, maybe at a later time if people really want to know why, but we're going to say http.register for our router. We're going to register it for a post method. So this is part of the HTTP spec. When you make an HTTP request, it has a method, a get or a put, or delete or post. Post typically corresponds to when I'm trying to modify or create or do something like that with the method. So when we're creating an album, I want to do a post method. And what this means with registering our router is that I'm specifically listening on the album endpoint only when the method is post. And then when a request comes in for album that's doing a post, I'm going to call this function, okay? Create album. What is create album? We're defining it right here, okay? Create album, what I pass to http.register needs to be a handler function, and specifically a request handler function. What is that? It's a function that takes as a single argument a request and returns a response. And we're cheating a little bit here, and I'll explain a little bit later why, but this isn't going to return a response just yet, but we'll get that later in like step 1 or 2 or step 2. So we have create album, which is a function. We're using the shorthand, function syntax here. It takes a request, a single request, and then what we're passing, and then what we're doing is we're basically passing directly to the service layer. And what we're doing here is we're translating from the HTTP layer, the HTTP input, which is the HTTP request object, and we're translating it into something that the service layer can understand, which in this case is going to be a JSON3.object. So when I call JSON3.read on the request body is just a byte buffer of whatever the client is passing in as their request body. If I pass that to JSON3.read, it's going to lazily parse that into a JSON3 object of key value pairs. You can think of it like a dict. And so it has keys, it has values, I can access those like a dictionary. And that's what we're passing to the service layer. And that's because the service layer can then use that object to do its validation and whatever it needs. So we're translating from the HTTP layer to something that the service layer can understand, because we don't necessarily in the service layer want to be doing request HTTP munging, translating itself. That's kind of the purpose of the resource layer, translating it from resource layer to the service layer. And then here we're using the return type syntax to say this method, right? This service.createAlbum should return an album object. And this is going to be defined in our model. Okay, so that's where that definition is coming from. We're going to export it from our model module. And so then we can just use it directly here to say, hey, when somebody creates an album, it should return an album object. And that's, you don't really need the return type declaration on there. That's more because I just wanted to be clear, we're defining the contract here. So when I create an album, I get an album back. Similarly here, okay, we're going to define another endpoint, which is a GET request for album, and then I put a little asterisk in here. And what that means is accept anything that is input here. So it's kind of a wildcard matcher to say they're going to call this like album/1 or 2 or 10,000 or some ID number. And I want to match all of those in my router. So any endpoint that comes in that is album/something, I want it to be caught by this route and passed to our get album request handler. So what does get album do? It takes the request, it's going to pass along to the service layer. But first, again, we're translating from the HTTP layer to the something the service layer can understand. And what we're doing here is the request target, rec.target is the actual what they called here. So album/something. What we're doing is we're splitting that path using http.uris, which is a URI aware version of path splitting. So it'll split smartly based on, HTTP URI stuff. And then we want to take the second, whatever is split. So it knows to split on /, and we're saying, I want this part of the URL, and then I'm going to parse that as an integer. Now, some people might, if you come from a Java background, you get like all antsy here because you're like, whoa, we're doing a lot of things without validating or checking if it's null and whatever. It's like, but that's kind of a good thing about Julia is we don't have to worry about that as much. So here I'm saying splits path, and I'm just saying, give me the second one. If there's not two, there should be two, because remember, we're saying that we're only going to route match based on if there is album/something. So we're going to match something, and there will be two things here. And then parse an integer. If it's not an integer, if they say album/hey or some string, then we basically want it to error anyway. And so if it can't parse as an integer, we're just going to let that error throw. And then they might have to realize, oh, that has to be an ID, so I need to fix that. So that's why we can kind of just keep this as a nice single line function definition for our handler. But what gets passed to service.getAlbum is just an integer, and it'll be an ID of an album that it can then go get. Okay, so that's why we're doing the translation there. With update, okay, similar dance here. We're actually matching the same route as get, but we're looking for a put method now. Put typically corresponds to updating something. So I'm updating a resource, which is what we're doing here. We're updating the album. And here we're actually doing both of the translations. So we're expecting them to pass in a album ID as a part of the path. So we're parsing that path parameter here. And then we're also looking at the body. And you'll notice that there's a difference here in how we're calling JSON3.read. So in create album, the user is passing in a few things. Remember, our model definition was like album has a name and an artist and a year. But we're just calling plain JSON3.read and passing that JSON3.object to the service layer to then validate things. With update album, we're expecting them to have already received from create album or get album a full album object. And so we're expecting them to pass back in the same, like basically a modified album object that they already got. And then they will have modified something and they will send that back to us saying, hey, I updated, I changed something in the model object. I want to now update that in the microservice. And so we're calling JSON3 with the request body, but we're specifically passing it the album type. And so this will, basically the return type of this is, ::album, because it is expecting to be able to construct an album object specifically from this, JSON3 byte buffer or JSON byte buffer from the request body. So that's a little bit of a difference there because we're expecting them to pass in a valid album object. Whereas here, they can kind of pass in whatever they want and the service layer is going to validate and say, oh, let's make sure they have all the pieces we need to create an album. And then we'll kind of brush over these quickly. The delete just does the delete method with the ID, and then it'll parse that and pass it to the service layer. And then we have our final endpoint down here, which is pick album to listen with a, we're just going to listen on basically the empty path. So this will match basically anything, and it's just a get request. And so we could name this something specific like pick album to listen to, but whatever, we just kind of want to have an endpoint that to catch here and pass that on. Notice that there's no parameters here. There's no translation. So they call this endpoint and we're just going to directly pass it to the service layer. And the service layer is going to figure out all the logic to do there. So this is our resource file. This is the kind of server side definition. And in the client file, we're going to have the client side definitions of all these. So again, we are bringing in the HTTP and JSON3 modules. This is for our machinery and translation of objects. And then we're also bringing in our model object because as we saw, some of these methods like get album are returning an album object. So I can parse that directly because I already have those model definitions available. Let's walk through create album and the logic we're going here. So I'm creating a function create album. It's the mirror image of this definition on the server side, which took a request. But now I'm saying that as a client, when I call client.createAlbum, you need to provide a name, artist, year, and songs. And what I'm going to do is call http.post, okay, right? Because we define that with our endpoint registration here. I'm going to call http.post, calling on the endpoint album, and I'm passing in these things as the request body, as a JSON, body. And that's how I'm going to call my server. Now, we're adding in an additional piece here because we actually need to call a full endpoint, right? On the resource side, as a server, I'm saying, yeah, I'm the host. And so I'm really just concerned about everything after the host part of the URL. So www.google.com, that's me. I'm the server. And so I don't need to worry about that part. I'm worried about anything after that. Are you going to Gmail? Are you going to, Calendar? Are you doing anything else? So in the server side, we're only interested in defining what are the things after the host that I'm listening to path-wise. On the client side, we do need to construct a for URL. So we're going to structure it like this because this will allow us to change this if we want later. So we could actually put something else as the server. But for now, we're going to say that the host portion is going to be localhost : 8080, which means, hey, I expect there to be a server running on the same computer as the client that is listening on port 8080 that I will be able to send a HTTP post request to. And then we're concatenating these using string. So this will create a URL that's like localhost : 8080/album. So that's how we're making our HTTP request. We're getting a response back. The resource said that there will be an album in the response. That's what's getting returned. And so I'm going to say, just like in our update album, when I say, hey, you're going to pass in an album, and I'm going to say JSON3.read, we're going to do the same thing with our client side on the response. So we're going to say, hey, in the response, I'm expecting you to send back in the body a album JSON serialized. So I'm going to say JSON3.read with the response body. I'm going to get an album back. So I'm going to structure Julia object back in the form of our model definition of the album. So, and then one more thing, let's talk through this syntax of the body. So this is new nifty syntax in Julia for name tuples. So typically in Julia, when you make a name tuple, you have to say like A equals 1 and B equals 2 and C equals 3, right? And that's my name tuple. I think it's as of Julia 1.5, there's new syntax where I can say A equals 1, B equals 2, C equals 3, and I can make a name tuple that is just A, B, C. And that's going to be the same thing as my definition up here. So it's really handy syntax. It takes the variable name and says that you're probably meaning that to be your name tuple key name, where we put the semicolon here in front to show that we want a name tuple instead of a tuple, right? Because if I just said ABC, that's just a tuple, right? There's no names here. But if I put the semicolon there that says we're going to be doing a name tuple, and then it uses the names of the variables to construct those. This is a feature of newer JavaScript as well. I don't know if it's TypeScript. I don't think it's TypeScript specific. It's JavaScript. Really handy though for things like this where I want a name tuple with these variable names, name, artist, year, songs, and I can just use the same variable names that I'm defining in my function. So this will create a name tuple that will be name equals whatever the name of the album is, artist equals whatever the name of the artist is, and it'll create a name tuple, and then JSON3.write, what that's doing is it's saying, oh, you're passing in a name tuple. I know how to serialize that to a JSON object, okay? And that's going to be the object that create album will expect, that we'll see. So hopefully that makes sense. These are just mirror definitions of our resource file. So we have a client side definitions of our endpoints of our contract, and we have our resource side. So that's kind of the gist of step one. I think I stepped through all the things I talked about. So I'm sure there's some Q&A. Let's go over there. Bentang, I know you mentioned how it handles input validation automatically. What about input sanitization? How sanely to handle HTTP header injection or cross-site scripting attacks? So yeah, it's a good question. We're at a low enough level here. We're defining our own microservice. And so we have full control over the request handling and response. And so as you can see in our resource, I'm getting the request and I'm only reading the request body here. So I'm not worried about any headers here. And so that's not going to affect my code here. So it's kind of naturally robust in that way. And like I said, in the service layer, we're going to do validation of the request body itself. So we're going to sanitize those inputs ourselves. But in terms of cross-site scripting attacks and that kind of stuff, that'll be a little bit more when we get down to the server definition. By default, HTTP specification says, hey, you can't do cross-site scripting unless it's specifically allowed. And so it will, it's going to catch the HTTP server we're going to use once we actually run this service is going to ignore those kind of things and handle those things automatically because it's part of the HTTP spec. And if we want to allow that, like because we're developing locally or something, we want to build like a little website that uses our microservice, then that's where we need actually, on our server side, we'd need some kind of middleware that says, oh yes, we can allow this from this domain or localhost or whatever to allow those kind of cross-site scripting things. So yeah, it should all be handled automatically. Would we be covering how we secure the endpoint? Yes, we're gonna walk through a little bit later, doing some user authentication. So we'll get to that point. What we're not talking about is like super intense, like Nginx level configuration around like endpoints and like DDoS stuff, or I don't know, like I'm sure there's like lots of crazy stuff. So our microservice is going to be kind of more simpler in terms of the endpoint configurations side of things. And that's mainly because in my experience, often you're not setting up a Julia server as like your main load balancer or your main like, you know, listener for the web. Typically when we're building a microservice, it's in conjunction with other microservices. And then we'll kind of put everything behind one master server, and we'll use Nginx or whatever to kind of handle all of maybe those complexities or proxying or whatever, you know, varnish, you know, reverse stuff that we need. Or having like a dedicated authentication server up front that's handling all of that, then passes it on to the service layer. So yeah, we're not going to go too crazy on that. So hopefully that answers that question. I'm going to let somebody else talk about Julia 1.5. Could you re-explain the need for ref string instead of just string? Yeah, sure. So in the client here, I said refs.string. What that does is it just allows us at runtime. So if I go here and I'm going to load music albums. Oh, no. Oh, because we don't have it instantiated. Okay, let's instantiate. So what that allows us is we're just going to be able to say client.server, and then we can mutate this at runtime. So I could load this package, and then I could change the server that I'm hitting like live, right? And then these functions will all pull whatever value is in the server ref at runtime to say, oh, I could switch, you know, clients that I'm using, you know, whenever I want. So right now it's here, but I could change this to say, oh, actually I set up a server at, you know, www.google.com, okay? And now, you know, it's going to use that host as wherever I direct my endpoint. So that'll just allow us to configure it later. It's not really, you know, that big of a deal. What was the reasoning for the ref string? Okay, so we just answered that one. So I just answered that one. And then in pick album listen, we're passing in a request to the handler. How is this not being, however this is not being used, is it necessary? So yeah, in the resource here for pick album listen, the request is required as a function argument here because it needs to be a request handler. And that definition comes from the HTTP module, which says whatever you pass, the function that you pass to the register needs to take a single request as an input argument. Whether you ignore that or not, that's up to you, and that's what we're doing in this case, but it does need to take a request as a single argument because you know, that's what HTTP is going to call it as. So it's going to call this function with a single request every time. So how similar would you say it is building microservices this way compared to vanilla Node.js? They seem to look pretty similar. Yeah, it looks like some other people are jumping in. Express, Node. Yeah, so this is meant to be very similar to other frameworks. Express, Node, Go has, you know, some frameworks similar to this. I've worked a lot with like Spring Boot and Java, which has a similar kind of layout. And that's the thing with microservices. Like I said, it's not like Julia specific that this is how we're building microservices. This kind of like across language, this is a typical kind of architecture. And so yeah, it's going to look very similar, and that's the idea, right? This is what people are familiar with. This is how you typically tend to structure things, and so we want that in Julia to feel very similar, so that it's not like this really foreign thing that people have to learn a whole new paradigm for just to build a microservice in Julia. Okay, awesome. How many requests can HTTP handle per minute? Does it work in parallel? We're going to talk a little bit about this later. I have a concurrency step we're going to get to, but HTTP should be very fast. At one point, it was benchmarked and it was on par with, you know, Apache, Tomcat, and Nginx and whatever, like some of the leading in terms of raw, how many requests it can handle concurrently. So it's really up there. Somebody did have a discourse post where they saw some kind of slowdown. I think it was using HTTP router with something. I never did get a chance to look into that. It's on my list of things to look into, was maybe there's something in the code there that's slowing something down, type instability or something, but it should be very fast. So we shouldn't have any issues in terms of how many requests, an HTTP server can handle. Why not HTTPS? This is a good question. So again, this is kind of coming from, I guess I could have stated this up front, but the assumption when you're building a microservice is that this isn't necessarily going to be your end all like main HTTP server. So a lot of the times, like I said, you're going to kind of put maybe an authentication server on top of this, or like an Nginx master, load balancer, okay, that's going to handle things. And so when you're dealing with HTTPS, it's often to your advantage to only have that initial server do the HTTPS dance, right? You want it to be secure, yes, but once you've kind of secured that initial request, like with your Nginx server, you typically want to translate that directly to just plain HTTP, because then we're kind of saying, hey, you made it past the gatekeeper of sorts, and inside we want everything to be more efficient and more text friendly and more everything. And so we're going to then translate to HTTP, plain HTTP. And so that's kind of why we're making the simplifying assumption here that we're just going to be dealing with HTTP. If we want to do HTTPS, then we need to, in our server definition, we would have to provide, valid cert, and we have to get that registered somewhere so that, it's trustworthy and all that. So that's kind of an additional dance we would need to do if I wanted my Julia HTTP server to be the gatekeeper. It would need to be able to speak valid HTTPS with a certified, certificate. And that's just not something I really wanted to go through in the workshop. So that's why not HTTPS. Is there a good introduction or book that would help understand more of the basics of the HTTP client server? That's a good question. I probably should have had a resource ready. I can maybe, if someone wants to ping me on Slack afterwards, I could come up with a few things. But there's a lot of good stuff on the web if you search HTTP kind of basics. The HTTP spec in general is one of those kind of basic things that I feel like all software engineers, programmers, even scientists should understand. It's like so foundational to everything nowadays that it's just good to have a basic understanding of, HTTP methods and request bodies and headers, a little bit how cookies work. I think those are just good basics for anyone to have a basic understanding of, because it comes up all the time. Like, just if we're setting up a simple microservice, or if I start using some web API, they're always going to define their API in terms of REST endpoints. So, hey, here's this endpoint and you're going to call this, if I want to hit like Instagram's API, they have an API defined. I can get a token, I can, call an endpoint and like get all my photos that I post on an Instagram kind of thing. They have a defined API like this that's listening for these routes, and I need to know how to speak that language, right? So I think it's to everyone's advantage to learn some of those things. And yeah, if anybody else has any inputs, Egghead is definitely good stuff. I know one of the guys that, helps contribute to some of that, really great stuff. So there's a lot of good tutorials and workshops and walkthroughs there. Okay, so I think we're gonna go to step 2. We are done with step 1. So if we go to here, so again, I'm going to go to my Git repository here. I'm gonna say git checkout step 2. Oh, and we're gonna stash the changes there because I instantiated the project and so it modified things, but we're not gonna worry about that. Git checkout step 2. So in step 2, what we want to do is the service layer and model objects. Now we're going to actually define those. We're going to fill in kind of the next step, right? So we defined our resource, and now we're defining our model objects. So does this keep getting moved around? You keep getting in my way. So I'm going to open up the model file here, and we're going to walk through the definition we have. So we've kind of already seen this, right? We kind of showed it in the slides. We have an album object. This is going to be our main model object we're working with, and it has some fields. So it has an ID, and I've kind of tagged these with comments to say that a certain field is service managed, meaning the user or the client doesn't, they can't modify those, and they don't get to pick them. So this is service managed. We're going to be providing the ID, and you can't change that. So the client can't update that. But what the client does provide are the name, artist, year, and songs. Okay, so we've already seen that. And then we have another field down here, which is times picked. And this is also a service managed object. And we could potentially allow, clients to like change that if they wanted to like modify that. But for now, we're going to say, keep things simple. That is a service managed. So we're going to be managing how many times an element is picked. Let's go in the definitions here. This is just an equals. So to say, hey, if two albums have the same ID, then they're equal. Not going to worry too much about that. That's just for testing purposes later. What we really want to talk about here is the struct types thing. Okay, so struct types is a Julia package, and it's actually used by JSON 3 to do all of its object serialization. So it's a package providing struct type trait to declare what kind of struct you are, okay? And that allows serialization, deserialization packages to automatically deal with your objects. So what we're defining here is the struct type of our model object, the album. And the struct type that we're declaring it as is mutable, which means there's like a whole definition here. If we go to the docs, okay. So there's data types. There's a struct type that you can be, but there's also a mutable type, and there's a kind of API. There's an interface. There's requirements here. So one of the requirements of the mutable struct type definition is that you have an empty constructor, okay? And the reason why here is because when I want to take a JSON, text object representation, and I want to create an album out of that, I want to deserialize an album from JSON, I need to know how to construct this thing, okay? Now, by default in Julia, when I just do mutable struct album like this, it creates a constructor like album ID int64 name string, right? And it takes all the arguments here, and then it'll actually create an album object from that. That's kind of the default constructors we get with our struct definition. So we don't, by default, have a definition like album, which would be the empty constructor. So we're going to define that here, right? And we're just going to pass some empty stuff. So ID is 0, empty name, empty artist. Doesn't really matter. I'm not really worried too much about these default values. If I was really worried about them having default values, and if I thought that would mess me up, another thing I could do is just say album equals new, okay? And then that's kind of a default way in Julia to say, I want to construct this object with no inputs. That means that immutable fields are going to be randomly initialized. So this will have a random value, might be 0, might be some garbage in 64. Mutable values are going to be undef. So it'll just be an undef ref error kind of thing. And so those will be like that. Now, I might want to also provide additional constructors, right? So I might say, well, I actually need to, I don't want to always have to, empty initialize it and then set the fields. So maybe I want to also provide another one. So it's just kind of a preference thing of whether you kind of define them as inner constructors, or here I've just defined them as outer constructors. So I want a convenience definition. Well, this is the required definition for struct type.mutable. And then I also want another constructor that is kind of my client constructor that just takes a name, artist, year, and songs, and fills in the service managed fields with 0 and 0. Okay, so I've kind of combined two default constructors here that they won't clash with anything. And this is to satisfy the struct types API. And like I said, this struct types is used by JSON3 so that JSON3 can automatically figure out, okay, given a random JSON, text representation of an object, how do I construct an album thing out of it? Okay, so that's our model definition, and it looks like I've made some changes here. I'm going to back up that. Whatever, we'll stash it later. And so then let's look at our service layer. So in the service layer, now we have the definitions that we already said we were calling in the resource, right? So it's kind of nice because we already know exactly everything we have to fill in. So we've already said we're calling service.createAlbum, service.getAlbum. So these are the definitions we now need to fill in our service layer. So here we're bringing in our model layer and mapper layer for now, but we're not going to worry about that for now. And then we're also going to use the dates module because we want to do some fancy things with that. So we said in the create album we wanted to do some validation. So the validation we're going to do is, remember, this object that it gets passed is just a JSON3 object, so it's like a dictionary, and we're going to treat it like a dictionary to do our validation. So we're going to say, hey, the object passed in needs to have a name key, and that name key needs to be not empty. So those are the only two requirements we have right now for the album. The other thing is we're going to say that it needs to have an artist, and that artist needs to be not empty. And you need to pass in some songs. So, and the songs need to be not empty. So we've already kind of had some definitions here. We could do some additional validation here to say, oh, and the songs need to be strings and they need to be not empty, but I digress. We could do a lot of validation here. And then we're going to validate year, and here we're going to be fancy. We're using some cool Julia syntax where you can chain comparisons here. So we're saying that the object.year, we asserted that it has a key for object. We're going to say object.year needs to be greater than 1900. Oh, I think we said in our slide it was being 1930, but whatever. We're going to say it's 1900, but less than, or we should probably say less than or equal to dates.year of dates.now. So this is kind of cool because we're being dynamic with our validation here, right? So as soon as we switch over from 2020 to 2021, our service will still be validating. So if someone releases their album, January 1st at midnight, 2021, and I want to input that in microservice, boom, it's going to validate. It's going to be okay because I have this dynamic validation here. Just being clever, okay? Dates.year here is just an accessor method. So we're saying, give me the year as an integer of dates.now, which is like a current timestamp kind of thing. Yeah, but we want that to be less than or equal to, because then otherwise we could only put input albums that were 2019. Okay, so now that we've validated our object, what we're going to do is create an album object. Okay, and this is from our convenience constructor we defined, where we said, hey, I've got a name, an artist, a year, and the songs, and I want to make an album. And that's going to fill in the ID and the times picked as 0. And then similar to what we did in the resource layer, we're just going to kind of pass the buck here and say, the only other thing I need to do when you create an album is store it. So I'm going to create a generic definition here, which is mapper.store for the album. So, hey, mapper, I don't care how you do it, go store this album and so that I can get it later. And then I'm going to return that album because I created this, right? Because that's what we said in our resource. Create album for the service layer needs to return an album. That's the contract we defined. So similarly with the other definitions, get album is really quick because we don't necessarily need to validate the ID here because we're just going to pass that on to the mapper layer. If the mapper layer can't find the ID, it's going to throw its own error. So it's kind of validated from that standpoint. For the update definition, remember we said that we have service managed fields versus client managed fields. And so I can't just take the object from the user as is, because what if you change the ID or what if you change the times picked? And I said that I don't want to let you do that. And so what I'm going to do is say, given the ID of the album you're trying to update, I'm going to get what we already have stored. Then I'm going to use your updated object to only update the name, artist, year, and songs. Then I'm going to store that back and return it back to you. So I'm basically ignoring in the updated the object that you sent in, that album, I'm ignoring the ID and the times picked because I'm saying I'm not allowing you to just pass in whatever you want there and change that. For delete album, again, we're just kind of passing the buck to the mapper layer to say, hey, I've got an ID, go, don't store this anymore. And then for the pick album listen, oh, here's our bread and butter. Okay, here's where we have our fancy logic. So the logic here for pick album listen is I need a way from the mapper layer to get all of the albums, right? I want to get all of my albums that I've ever created before. And then what I need to do is find what is the least number of times picked across all my albums, okay? So if I have 4 albums that have never been picked, they have all of times picked equals 0, I'm going to find that. That'll be the minimum across this array of albums. And then I'm going to filter all my albums based on who is that least times picked, right? So I'm going to get all of the albums. These are kind of my candidate albums that I want to listen to because they've all been picked the least amount of all my albums. And then I'm actually going to pick my album, which is rand on least picked albums. Really fancy here, okay? So I'm just going to, of the albums that have been picked the least, I'm going to pick one randomly. I'm going to increment the field here, which is times picked. And then I want to make sure that I store this picked album, right? Because I just modified it. I just updated this service managed field, which is times picked. And so I want to make sure I store that. I kind of stamp, take a record of how many times it's been picked now, and I'm going to return that picked album. So there's kind of our fancy, business logic, if you will, of managing my record album here. And let's go check my slides and see if there's anything else I needed to talk about here. Step 2, service model definitions. We talked about struct types, service managed versus not, equals for testing purposes. And then we did create album, pick album, listen to. Okay, so that's step 2. That's our model and service layer. I don't see any questions, so we're going to move right along to step 3, which is our mapper layer. So if I go to my terminal, I'm going to say git checkout step 3, and I made changes, so we're going to stash those again and say git checkout step 3. So here we're going to do basically the most minimal mapper definition possible, just so we can get our service kind of up and running. So what are we going to use for our fancy persistence? We're going to use a dictionary, plain Julia dictionary. We're not interacting with any databases here, okay? So yeah, we're kind of copying out here. So we have our store, which is a dict. It's going to map album ID to album object, okay? So we brought in our model definition here. So we have our album, definition available to us. And then the other thing we need to do is this ID, we said that we are going to manage the.
That's my audio.
You just cut out for a brief second. I can't hear you.
You've muted yourself, Jacob.
Okay, Zoom. I need to redo my password here. Okay, can everybody hear me again?
Yep.
Okay, sorry, my headphones freaked out there. They restarted on me. Okay, so I have a counter here, which again, we're using a ref. I want a mutable thing that I can increment as I get new albums that come in. And we're going to start off at 0. this is what I'm going to use to manage our album IDs that we said we were going to manage as a service. So let's see how we manage. We said that we needed a way to store. So that was like from our create album, right? We created an album, and then I just said mapper.store on the album. So let's see that definition here. So it kind of depends on if we've already seen this album ID or not, right? What we do with it. So if we haven't seen it, right? If our store does not have that album ID as a key, then I'm going to set the album ID by incrementing our global counter here, okay? So I'm gonna increment the global counter. So the first time this called, this will get incremented to 1, and I'm setting that as my first album.id, and then I'm gonna use my global dict store here to store the album ID, and I'm gonna store the whole album that is coming in from store. Boom. I'm persisting this album. That's awesome, okay? Super simple, but gets the job done. If I have seen this album before, I'm going to actually use that album ID directly. I'm not going to increment my counter. I'm going to use the same ID. And so that's going to replace whatever is in the store currently, and I'm just going to replace it with the album coming in. So this is the updated album, and we're going to store that. For get, I'm just going to call store with the ID. Like we said, if that ID is something bogus, if you call it with a number, an ID that doesn't exist, then this will throw a key error with the dictionary indexing. If with delete, we're just calling our dictionary delete method on the ID, so that'll get rid of the store there. And then for get all albums, remember we needed that for our pick album to listen. We said we needed a way to get all the albums and do some logic there. And so we're just going to collect the values of our store, right? So you input all of your albums and they're mapped from ID to album. And so I'm just going to call values on the dictionary, which give me all the values, and then I'm going to collect them into an array. Boom. That gives me all of the albums for that you've stored in the microservice. So yeah, super simple definition. It just gets us something that works, right? That's all we're kind of worried about right now, is getting something that works. We're worried about making this a grown-up, mapper layer later on. So we have a question here. Are you using the empty returns to ensure nothing actually gets returned up the stack? Yeah, you could say that. It's really just kind of a code cleanliness thing for me. I know that in the service layer, I said, mapper.delete, and I'm not in mapper.store, and I'm not using the return value of that at all. And so that's just kind of a cleanliness thing. It's kind of an organizational thing in my mind to say, I'm not expecting to use the return value of this. So if I accidentally did in the service layer, I would get an error and it would be like, oh, you got nothing. And I'd be like, oh, okay, maybe I need to return that, or maybe I don't. Why do you define counter as a ref? What does the ref do? Can't you do const counter and then counter 1? I think that technically works in Julia. I think you can modify, because I think when you put const on a thing, where's my mapper? Then you can still modify the value. It's just saying the const is on the type of the thing, but this is kind of like a cleanliness thing for me. Like I'm actually mutating like the value. So like conceptually, it's just easier for me to think about it that way, right? Because I'm kind of saying that I have a box sitting there, and whatever my current ID globally for the albums is, I'm kind of putting in the box. And then when I increment that, I'm taking it out of the box, incrementing it, and putting it back in the box. And so conceptually for me, it's just a little easier to think about it in terms of using a ref and taking it out of the ref and then putting the updated value back in. So that's kind of why I use a ref, but I think technically in Julia, it would work if we didn't use a ref here.
Jacob, I think it works in the REPL. I think it's undefined behavior in a script.
It actually just doesn't work. When
it
you
doesn't
increment
work.
an integer, you're actually assigning to it, right? Like plus equals is just saying counter equals counter plus 1. And when something is const, you can't reassign to it.
Okay.
One other question, Jacob. In the store function, how are you handling the default value? since all of the albums start with an ID of 0.
You mean here when I set the album.id?
Yeah, because
Or-
then when it comes in, wouldn't it always have the key? Because it would start as 0. Or because we did the counter plus equals 1, we're good.
Yeah, I'm not sure.
0. Okay.
Yeah, because so this right here, this is modifying the ref here, right? So when this gets called in the first time, I'm saying pull the value out of counter 0 plus equals 1. So that'll be 1. And then we're storing that back in counter, right? So this will now be 1 after the first time we called it. And then 1 is it's what gets returned by this, right? So then album.id will be 1. And then we'll say store of 1 is album. Does that make sense? Or is there?
Yeah, thank you. I was thinking the 0 got stored on the first one, and I was like, infinite loop of 0 IDs. But
Yeah,
that makes sense.
yeah. Yeah, so we're being a little bit tricky here because we know that the return value of this increment operation is the incremented value, so it's 1. So we could split this up, We could split this up into 2 lines, right? And say counter plus equals 1, and then say counter get index, right? So it's more 2 explicit steps. I'm incrementing my global counter, and then I'm setting my album ID to the current global counter. But yeah, I was just being fancy and putting it on 1 line. Okay, so we're gonna move right along because we got a lot to talk about here. So let's go to step 4, which is, hey, let's actually run our service. So go to here. I probably need to get stash again, and then I'm gonna say get checkout step 4, and let's actually look at the diff. We'll do it in VS Code because it's already like, nope, not that one here. Compare branch. Step 4 was step 3. So to actually run our service, right? Because we've kind of defined all the layers. We have all these definitions. If we actually loaded the code, then it wouldn't, in step 3, I'm saying, it wouldn't actually throw any errors. Like before, it'd be like, whoa, mapper.store, there's no function defined there, you know? But now we actually have all the functions defined, but how do we actually run our microservice? So here in step 4, we're gonna do it. So in the music albums module, we're going to add a run method, okay? And that's so that we can actually have something to call to kick everything off. Now, what do we need to run? Well, we've said that the resource layer is where we're defining where the clients interact with it. So it's probably there, and it is. So remember we defined this HTTP router, which is this object that holds this logic in terms of, you know, when a client calls for this endpoint, we're going to call this handler. So we've kind of set up all of these code paths that are going to route incoming requests to the different service layer, functions. So now we just need to actually wire this up to an HTTP server. So we said that when we run our microservice, we're going to call resource.run. So we define a run function there. And what it calls is http.serve, okay? So this is a HTTP method that will start a server listening on a specific host and port. So that's what these 2 arguments are here. The 0.0.0.0 just means I'm kind of listening on myself, on me as a box. So this is kind of a standard way when you're running an HTTP server to have it run. You could also say localhost if you wanted, but then it wouldn't be accessible from outside your machine. But this just means I'm listening on my machine and anybody can hit me. And then I'm listening on 8080 port. This is kind of a random pick, but it'll come in use later when I show you how to deploy this on Google Cloud Run. And then the other piece, the other argument here is the first argument we passed HTTP server, http.serve is a request handler. And this can be anything that satisfies the http.handler interface. So I actually have, no, that's not what I want. Sorry, you go away. Oh, I don't have the other one. Oh, I do. Here it is. So there's the handlers module in HTTP, which defines, where is it? Where is it? Where is it? The abstract type handler. And so you need to pass something that is a handler. And a handler is something that satisfies the http.handle method, okay? So this is kind of a standard way in is kind of the standard HTTP middleware machinery is you can call http.handler with a handler and pass it a request or a stream. We're not going to talk a lot about streams, but they're just a way to do like, they're not fully materializing the request body, but you can kind of stream it, okay? But that's kind of the difference between a stream handler and a request handler. So a handler is anything that you can call handle on with a request or a stream. And a request handler is specifically a handler function that takes a request. And a request handler function is just a plain function that takes a request and returns a response. So we're hooking into this machinery, okay? Because http.serve it'll start a server, and when it gets a request in, when a client actually calls your server, it's going to call this function with a request, okay? Or rather, I should say, it's going to call http.handle with request handler, and when you pass in a request handler function, it'll call it with the request, just to clarify. So in our request handler, okay, so we're defining our first bit of middleware here, right? So middleware refers to anything that you do to a request once it comes into your service and before you kind of pass it on to a dedicated service layer. So this is our first bit of middleware, and it's our top level request handler. So we're going to get a request, and all we're going to do is we're going to then we're going to basically pass it on to our router, okay? So an http.router is a handler, okay? So if we go down to the struct router definition, okay, it subtypes handler. It is a handler type that implements the handle interface. And I can't find that. Let's see. Function handle. Request handle. Nope, do it on it. It's down there somewhere. Okay, so a router, it implements this function. So you can call handle on a router and give it a request, and then that's its job. That's what the router does, is it figure out which of these methods should be called given the request method and the request input. So that's the router's job, is to route the incoming request to all of these different request handlers that we've defined that can then pass it on to the service layer. So that's kind of this cool thing. This is where we're hooking into the HTTP middleware stack, is we're passing the request to our router. And then up here, you remember I said we were cheating a little bit because the service.createAlbum was returning an album, but in the handler framework, we said that the handler should take a request and return an HTTP.response. So that's where we're being a little bit clever here by saying, I know that everything returned from my router handlers, okay? So pick album to listen and delete album. I know that these are all returning plain Julia objects like album. And so I'm actually going to handle that in my request handler to say, this is where I will wrap all of the return objects in an HTTP response. So I'm going to put a 200 here, which means it was good. This is a valid HTTP response. And then I'm going to JSON3.write the object, okay? So whether that's nothing or an album or whatever, we're going to serialize that as JSON and send that back to the client, okay? So this is where we're actually wiring up our service and making all the pieces talking to each other. So we will now be able to call our service like musicalbums.run. And the other thing we've added is a test file where we can actually run some of our run our service here. Okay, Let's look at the question here. Have you found time to first request to be a performance drawback of Julia versus mainstream Microsoft frameworks? Excellent question, Raz. Yes, so the time to first request is a thing, right? Because in Julia, everything's JIT compiled. So the first time somebody calls an endpoint for your HTTP server, it has to compile a bunch of methods, right? It's got to compile like TCP methods for setting up the socket, and then it has to call this function that's like passing it on to, task handling code, and then it has to pass it on to the handle method. It has to compile that method. And then if we have a router involved, it has to compile the handle method of the router. And then then we hit our service layer. So then we have to compile, where's our resource? It has to compile the resource handler, and then the service layer, and then the mapper layer. It has to compile all these functions the first time that your service gets run. So there's definitely a compilation cost for that first request that comes in. Now, oftentimes that's not practically a huge deal, right? Because if you're setting up a microservice, you're kind of expecting to run for, a long time. So having just that first request be slow, it's maybe not that big of a deal, because all of the subsequent requests they're automatically compiled, and, we won't have any more issues. Assuming that we don't have any like type instabilities or like dynamic compilation going on, which that's a bigger problem, and we need to address that, code wise. But I'll show you later, using package compiler, we can actually overcome this time to first request, compilation. Basically, we can run through the different code paths in our microservice during a compilation step, because we know these routes, right? We have a defined code paths we're going to be hitting and that clients are going to be going through. So we can run through those in a pre-compilation step and save that compiled code in a system image, and then deploy that for our final microservice. And I'll show you how we're going to do that later. Done. And then Lyndon says, what would I like some kind of thing in the request so that if an exception was done, to give HTTP error code, maybe display the error user response body. Let me answer live. Yes, good question. So HTTP server by default, if you throw an error from your request handler, it's going to wrap it up in a 500 and send that back to the client. It's not going to have anything super useful, but I'll show that in the next step. We're going to get there. So yes. And then it's what I do. Also, not everything is 200 response, delete. Yeah, so good point, Joris. Yeah, so I mean, you can return a 200 with delete. You could return what is it, like 203 or something for the delete. You could be more precise with your HTTP responses if you need. And that's where maybe in our resource file, we would actually want to not be clever and return album objects from these handlers. Maybe we would actually wrap those in responses themselves so that we could provide a different response code for delete. But this is just kind of a convenience thing that I'm doing for now for the step through. Okay, how to send the response as a stream rather than materials at the server? Suppose the response is a PDF file with music album cover. Yeah, good question. So that's where you would want to dive into the stream handler function part of the handler interface in HTTP. It's definitely doable. You just your handler function, instead of taking a request, it takes a stream. So in HTTP, that's a full thing. It's an object. It's a stream. It's more of an IO like object where you read your stream, and then you can also write out the response. Okay, so that would be in our resource where our handler functions would take streams if we needed to stream something in, or in our request handler here, maybe we would want to wrap this up in a maybe we want our top level request handler to be a stream handler instead. And so then we would actually pass in, I think it's just stream equals true is how you do that. And then a stream will be passed to this request handler. And then I could actually write out the response. So the stream handlers get a request and a response already created. And then I would write out to this response stream. So yeah, that's definitely possible. And if we need more docs in HTTP, just open an issue and we'll do it. But there's pretty good docs in the http.handlers module for all of this. So yes, definitely possible. And if you need to do that, you can do that. Is this going to behave in an async non-blocking way? Good question. So HTTP server by default, this guy down here, each request that comes in will be async handled. So so each invocation of request handler will be in a different green thread. It's not using multi-threading at all. So it's only relying on green threads. But in this case, we are dealing with IO. So these are TCP sockets that are getting opened and read from. And so each time we're doing that, it's a chance for a task switch. And so by default, we're getting some concurrency with our HTTP server in terms of requests that are coming in. But as you may have noted in our code, we don't have any async or spawn or anything like that. And so yes, once we hit request handler, this is a blocking call all the way until we return this response. So all the way down through the resource handler and the service layer and the mapper layer, those are all blocking until we get back to this call. And we're going to talk a little bit about that later in terms of how do we, think about concurrency in these ways and handle that. So good question. I'm new to Julia Microservice. How can I benchmark check performance of my microservice? Good question. I would just get to a spot like this with your microservice where I have something that I can run. I would start the server. I would hit it with a request or two to warm it up, right? To pre-compile that if I haven't done like a package compiler step. And then I would just use benchmark. So it's always a little bit messy when we introduce kind of networking into the picture. So there's latency involved and stuff like that. But if I'm running on the same machine, then hopefully that won't be as much of a factor. And then I can just use the benchmark tools package, which is great. So benchmark T tools.jl, and it has a really nifty B time macro or a B benchmark macro that will basically spam, call a service. So we could use one of our client calls and say benchmark against our service and be able to see how fast it is. And with something as simple as this that we've set up so far, we could, probably write the same thing in Node or Go and benchmark those versus ours and just get a feel for like how fast that is. So yeah, good questions on the benchmarking. How does all that compare to Genie? So Genie is like a bigger picture thing. So it's similar in a lot of ways. It's a framework for building microservices, but think of it more like in Java you have Spring Boot, which is like this whole thing, and you're using that framework. Versus everything I've showed you so far is trying to be as minimal as possible. So we're only using like the HTTP package and the JSON3 package, right? Like our project file right now is very minimal. We only have HTTP, JSON3, and struct types. Those are the only 3 dependencies we have. And we're able to set up a simple service with routing and all of these things. Genie is a full framework and it provides a lot more tools and services. So it might be a better place to start out if you want to kind of set up a whole full service and kind of have everything ready to go. But I'm showing kind of an alternative of like, these are kind of all the tools that Genie is using underneath the hood, right? So I'm kind of showing you one layer down from Genie in terms of here's all of the tools that it's using under the hood to set things up. And that's mainly so, I want to help people understand that, sometimes you don't need like maybe a full framework of Genie that pulls in like a bunch of database, whatever stuff, if you're doing something really, simple or, you want to manage dependencies or something. But yeah, Genie's great. It's just a full framework and I'm kind of showing what's under the hood there. Okay, did we walk through? Oh, we haven't run it yet. Okay, so if we go here and we restart Julia and we say using music albums, we're going to get something that we can actually run. And we set up our run tests file here. So the first thing we're going to run here is our server. We're going to run it in the same Julia process. And I'm going to do that by saying async. So that's going to start the server in an async task, okay? So that's this. So server is actually a task and it's runnable. So that means it's running in the background. If there was an error, then it would be like, it would complain and be like, the task stopped and something happened, okay? But now what we can do is we can actually run this. I don't know why this is so small, okay? So here I'm going to use my client method. So remember, oh, okay, I'm in the wrong window here. Sorry. Okay, here we go. Client. Okay, so remember we defined all these handy little methods here in this client module so that we could call our own service. So notice that I'm not calling music albums .service create album, right? That's a method. I could call that directly here if I wanted. I'm not doing that. I could also call resource.create album, right? That's also another method that I could call with a request if I wanted to craft a request. No, what we want to call is we're going outside of our service, okay? We're going to do the client, which is going to go through the HTTP route. It's actually going to make an HTTP request, send it to whoever's listening on this machine on port 8080, which turns out is what happens in our resource file from our HTTP server, right? It says that it's listening on port 8080, okay? And then it's going to do this HTTP post and read the response for us, okay? So let's actually go here. This is one of my favorite albums, Free Yourself Up by Lake Street Dive, released in 2018. I didn't put the full album songs here just for brevity, but we're actually going to create this album, okay? So I'm going to go here, I'm going to paste this in my REPL, go, and the lag here is what we talked about. There's all these methods that are getting compiled, both on the client side and on the server side. So that returned, and you can see that we have this object here, and what did it return? It returned an album object. So we got a Julia object back out, and that's because, remember, in our client definition, we said JSON.3, read the response body and return the album, okay? And we have all these things in here. So it has an ID, which is 1. It has a name, which is what we gave it, okay, when we called the method up here with create album. It has songs that we gave it, and it has times picked, right? Which is 0. So it's never been picked before because we just created it. So let's go back here and let's actually pick an album to listen, right? This is our endpoint, which is going to look at the albums we've stored, and it's going to pick one that we haven't listened to before or that we've listened to, you know, the least. Now, in this case, we know that our album is the only one. So we would expect, and we can actually test. I don't think I actually did using test there. So we're going to bring that in. We're actually going to test that what we get back from client pick album to listen, right? I'll run this just here so that we can see it happen. Is our only album, okay? And it looks like that is the case. And so I could actually test that album 1 equals album 2, okay? And that test is going to pass. Now, the one thing we should look at with album 2 is there's one thing different about it, and that is the times picked, which is now 1 because it's been picked once. So our service layer worked. We could maybe add in, you know, a test here to say, test that, you know, album 2 times picked equals 1, okay, because that's what we would expect, and we would expect that test to pass, okay? So we could do that as an additional test. And then I added another test here just to ensure even if it's been picked once and I pick it again, it's going to be the same album. There's only one album, so it's always going to be the least picked, and it's always going to be the album that gets picked. So we can keep testing that. We could also test our endpoint to get the album given the ID. So we're going to use the ID from the model object that we got back, and we're going to call that. And sure enough, we get that back. So that's great. And then we're going to modify our album here. So another one of the songs on the albums is called Shame, Shame, Shame. So I'm going to add that to the model object that I got back from create album. So now that's modified, and we're going to call update album. Okay. And once that returns, this is the object that gets returned, and I can look at the songs on there, and sure enough, those that got modified. Okay. So it updated with the new songs that we put in there. And then we could also delete the album if we wanted. We could create another album, a great old jazz album called Haunted Heart by the Charlie Hayden Quartet. We could create some more if we wanted, but you get the idea. So now we've kind of exercised all these paths in our service, and it's working. So our service is working. Our server is responding to the requests, passing to the service layer. The mapper is storing things. We could actually check that if we wanted. We could look at our mapper store and see, oh yeah, look, there's our album. It's stored in our mapper, okay? Yeah, anyway, so our service is running. That's great. We could deploy this somewhere, and it could be running, and we could call it with our client, and everything could work. So this is kind of our, we made it to step one, and everything's working. So let's answer some questions. This isn't persistent though. If your server goes down, we lose our albums. Yes, good point. This is a, it's only going to persist as long as the Julia process is running. So yes, we're going to address that next. At this point, what happens if you send a malform request? You get a server side, or do HTTP handles it and send a response with the right error code? Yeah, so HTTP serve, the default server will handle errors for you. So if an error is thrown somewhere, it'll return a 500, which is internal server error, which means we don't know what happened, but something went wrong while the server was trying to handle this request. So yes, that will happen by default. How many concurrent requests per second have you been able to handle? I can't remember. I think it was a couple thousand or something. I don't know. I can't remember. We'll have to look at that. I'm planning on doing some more benchmarking stuff with HTTP, and maybe we can put that up somewhere. But I think it was somewhere around 1,000 like concurrent requests or something. So sorry, I don't have a better answer there. Okay, so we're going to move along here. So we've done step 4. Our service runs. Oh yeah, you might have to call resolve to not get warnings with stuff. I guess that worked out for us. But yeah, we did all of that, and we got in our services running. So let's actually grow up our service a little bit. So we know that we kind of cheated in our mapper layer, because we just said we're using a dictionary and that's not persistent. Okay, so let's actually grow up our persistence a little. So we're going to do get checkout DB. We're going to get stash anything. Okay, so that we have a clean thing. And then let's actually look at the diff here for our DB branch versus step 4. And the biggest changes here are going to be in our mapper file, where we're switching to using a SQLite database. And we're not going to get fully persistent yet. Okay, we're still going to only be valid for the life of the servers running, but it's a step in the right direction, and we'll get there eventually. Okay, so here, what we're switching to, we're not going to worry about the diff over here. Maybe I should just open up the mapper file, since it's all new code. So we're switching here is we're going to have a DB ref, which is going to hold a SQLite database connection. We're going to define a function that is getDB that's going to pull our database connection out of the ref. Okay, so it's just a convenience function. We still have our global counter that we're going to use. Okay, and then we're going to do an init function for our mapper. Okay, so this is kind of our setup function. So when this module is first loaded, it's going to call init once it loads. And what it's going to do is actually create a in-memory SQLite database, store that in our ref, and then we're going to execute a command, which is going to set up a table for us, okay? So DB interface, this is a package we're now using along with SQLite. DB interface allows us to have a common interface for lots of different databases. It can take a direct connection or a function as the first argument, but it needs some kind of database connection here. So we're calling getDB to get our database out. and then we're creating a table here. So what we're going to do is create an album table to store our model object. So remember our model object here, we had different things, ID, name, year, times picked, that we need to store. Before we were just storing them in a dict, we were just storing the model Julia object itself. Now we're translating this to the SQLite database format, if you will. So it's a relational database. It has columns. They're going to mostly map to what we the types that we stored in our thing. The one thing that I want to point out here is that we are going to store our albums in a slightly denormalized state. Okay, so I did include a normalized file here if people want to see what a normalized setup would be, because note in our model object that we have this vector of songs. Okay, and so if you're thinking about a database table and one row per what is one row in a table? We could think about it as like an album table. You would think would have one row per album, and that's fine. And we could do that, but that doesn't work with our songs. How are we going to store our songs when there are multiple songs for a single album? Well, in the normalized code, we would have a separate table for the songs that would say, for this album ID, maybe there's a song ID, and here's the name of the song, okay? And then we would have an album table, which is one row per album. And then when we wanted to get the album with all its songs, we would join them together and pull them all in. We're not going to do that for ours, because it turns out it can be a lot simpler if we just deal with a little bit of denormalization here. So in our album table, we actually have one row per album per song, okay? So these are the rows are going to be unique based on ID of the album or name of the album. I guess you could have albums with duplicate names. So ID of the album and then name of the song. Okay, so songs is actually going to be, each row is a different song. And that denormalize is just kind of simplify things a little bit for us. And then we're going to be good citizens here. We're going to create an index on our album ID, because we know we're going to be pulling those out and we want that to be fast. So the way you do that in SQLite is by creating indexes on the columns that you'll be filtering on. So when we first load the mapper module, we're now going to be setting up an in-memory SQLite database. So now we need to change all of our definitions, right? So we had our service layer, and we're actually going to modify our service layer just a little bit, because we want to differentiate mainly between when we create an album and then when we update an album. Those are a little bit different operations for a SQLite database. So we're not just storing it anymore. We're actually separating out create versus insert, so that we know when it's new versus not. Otherwise, we would have to do an extra query in the database to say, does this album exist yet? If so, increment our counter. Otherwise, update it. And so we know from the service layer whether they're updating or creating. And so we're going to split those out in the mapper layer. So let's take create. We still are using our global counter, okay, to manage our album IDs. And then we're going to call this new function insert, which is calling DB interface execute many. There's a few things to walk through here. So I'm going to take it, how about we go inside out? So first we're doing DB interface at prepare with a get DB. So we're passing it a function to get a database connection. DB at interface prepare is going to prepare the statement. So we're going to actually, depending on the database, this can actually compile a statement. So it's more efficient to execute many times. And then we're passing that statement to execute many, okay? So the statement we're passing is insert into album, ID, name, artist, year, times pick, and songs, values, question mark, question mark, question mark, question mark. The question marks here are parameters. So that means that we can compile this statement once with these question mark parameters, and we're gonna fill these in like iteratively. So we're going to do it many, many times. We're going to execute this one statement many, many times, and we're going to fill in different values for these question marks time and time again as we create as we store our album. The reason that we're doing execute many is that, remember, our album table is storing 1 row per album per song, okay? And so we're going to insert as many rows as there are songs for our album. So insert takes an album, and then let's talk about what we're doing here. What is strapping.deconstruct? The strapping package, strapping is a package that also uses the struct types package. What it does is it provides an ORM-like functionality. And strapping stands for struct relational mapping. Basically, it wants to take Julia objects or vectors of objects and translate those into 2D tables, if you will. And that's literally what it does. The strapping.deconstruct will take a Julia object and produce a tables iterator from the tables package. And strapping construct, which we'll see down here, takes a tables iterator, a tables source, and it'll construct a Julia object representation. So this is common in other languages known as ORM. So it's object relational mapping. So we're trying to map between our Julia objects and a 2D relational representation that databases typically understand. So here we're being really fancy, okay? And I'm sorry this is like there's so much going on here. Hopefully everybody can follow, but we're taking our album, we're deconstructing the album object with fields into a tables iterator. So it's turning it, and column table is materializing it into an actual table. So it's a name tuple of vectors. And so we're turning our Julia object of album into a table that DB interface can then use to execute many times. So it's going to execute this statement for each row of this table. So we're basically turning our album into the representation we want to store in the SQLite database. That's the gist of everything we're doing here. And hopefully that makes sense, but it does work. But that's what we're doing with create. And then we're actually doing a similar thing with update. Now with update, the update operation just basically becomes delete what's ever in the table. So down here, we're saying delete from album where ID equals ID. So we're going to delete everything in the table for that album ID, and then we're going to reinsert it. So that becomes our update, is a delete and then update and then an insert. And then let's go through our get here. So our get is we're just select star. So we're just getting all the columns from album where ID equals whatever ID we're interested in. So, and then we're passing that to strapping.construct, okay? Strapping.construct says, I'm going to take the 2D representation of columns, okay, that are stored in the database, and I'm going to translate that into a Julia object, okay? So it knows to do the translation of, hey, I know that there's 1 row per song, and I know to collect those into a song's vector for 1 album object. Now, you might be wondering, how can it be so clever? What if I have multiple albums? How do I, because we run into that down here, right, with our get all albums. Now this becomes just select star from album. We're just selecting all of the albums, but you might be wondering, how does strapping.construct know how to differentiate? Here's this batch of rows for this album. Here's the next batch of rows for the next album. That's where we can rely on the struct types package again. So we go back to our model definition, and we've added a definition here. Okay, do we have that in our? Oh yeah, here you can actually see the diff. So we've added a definition here for struct types ID property. We've defined for the album that it has a field that differentiates it from other album instances, okay? So if an album, right, and that's from this definition here. If two albums have the same ID, they're the same object. If they have different IDs, they're different objects, okay? And we've defined that here with struct types to say the ID property of album is the symbol ID. So that's this field. So it knows in the mapper, that's how it knows in the mapper, that when I'm constructing a vector of albums from all the rows of the album table to differentiate, because it's basically scanning through those rows and saying, oh, all of these IDs are the same. That's one album object. Here's all the songs for that. Oh, here's a new album. I'm going to collect this as another album object. So hopefully that makes sense. But this is kind of a common tool in other languages where we're using an ORM translator for us. So we're translating from a 2D relational table representation of our object to our Julia object. And we're using strapping and struct types to help do that. But that's the bulk of the changes we're making here. So let's look at some questions. Are you using these ref type as some kind of encapsulation? Yeah, like I said earlier, it's just kind of a mental model thing for me where and in this case, it's also, I should add, it's kind of a pre-compilation thing as well. So notice that when we ran our Julia service, when we first said using music albums, it said pre-compiling music albums. So Julia does do some pre-compiling. It does parsing and lowering automatically. And so we couldn't, for example, do const db equals SQLite db like this, because that's not going to be valid when I load the package. So I need to wrap this up somehow. I need the database to be initialized at runtime. And so that's why I'm putting it in this init method. Is this ensures that my SQLite database is set up at runtime and stored in the ref. And then I can pull that out later anytime I need with this getDB convenience function. Hopefully that makes sense. So songs is one song, not a list. Why not use NoSQL database? Yeah, so hopefully I kind of talked through that a little bit. Songs is a vector and we're storing it denormalized in our table. So songs is one row per song. We're just translating that using the ORM to go back and forth between those two. We could use a NoSQL database, definitely. That's kind of like what we were doing with our dict, where we were just storing the whole object. Definitely an option. I'm just trying to show, for example, with a relational database, how we can use strapping to translate between those. But a NoSQL database could definitely be a great option here. Could ID property more and more complex, like a tuple of ID properties? I could, yeah, so you can definitely use the manual. I think for now it has to be a single field to be the ID property, but I think that could definitely be expanded. So I think it could be multiple if we wanted. So we could enhance strapping or struct types to allow that. How can I use individual sessions for individual users? Hold your question. That'll be the next step. We'll get there. Okay, so I think that's everything we wanted to cover.
Jacob,
yeah.
We're about 2.5 hours in. Is there any time for a break or should we head straight through?
I think we should head straight through because, yeah, I kind of have a lot to cover. I didn't realize we were going so slow. So I think that's everything we wanted to cover in this one, though. So I think we're actually going to, we'll brush over the next step really quickly. So I'll go through this one really fast. We won't actually run anything here. So we're going to say git stash, git checkout basics. The only thing we're really adding here is we're making the SQLite database configurable. So, oh, and I also do expiring caches. I added that in. So basically I switched from using an in-memory SQLite database to passing in the DB file. And then I changed it from init, which gets run automatically by Julia when it loads the module, to an explicit init function. So that means when we actually run our service, we need to call mapper.init with the DB file, okay? So we're changing how we're running our service here, saying, hey, you need to provide the SQLite database file that is persisted somewhere so that it can persist across sessions. So this is how we're achieving persistence. That kind of came up earlier, but now we're passing it in as basically a config thing to running our service. which gets passed down to the mapper. And then if it's a file already, then I'm just gonna set it basically. If it's not a file yet, that's where I still need to do the setup, right? I still need to do that initial create table setup. And then I'll just briefly talk through, oh yeah, we kind of enhanced the request handler here to add some logging. So I did some basic logging here. I added my own like error handling so that if an error happens, then we kind of serialize the error message as a string and return that in the response. So we're kind of making a fancier 500 error here. So the client would actually get back like the full stack trace of what happened in the service. You may not want that. That might be confusing for clients, but while you're prototyping and building a service, it's really helpful. And then there's a new package I just registered called expiring caches. It provides a way to cache the results of functions. So it's kind of a memoization functionality, and you can provide it a time period for how long results should be cached. So you use it like this, you say cacheable on a function, and you provide how long you want things to be cached for. And then you also have to provide the return type of the function so that it knows. That's kind of an internal detail of how it knows what to expect when memoizing. But here I just kind of threw an example on there where we're caching the result of get album. So maybe the database call is really expensive. We want to cache this. A lot of the times this is useful when you're calling like other services. So if my microservice talks to another microservice that might be doing something expensive, I might want to cache the call to that for an hour or something. And then the other thing we can do is we know that when we update the album, that invalidates the cache, right? So we have this a way to get the cache of the function get album, and I can actually delete I can invalidate the cache for a album ID. So I'm invalidating the cache when I delete, and I'm also when I delete the album to make sure that, you know, if I didn't invalidate the cache when you deleted the album, you could call get album with the ID and still get it back because it's in the cache, even though it's been deleted in the database. So we want to invalidate the cache there. But you can look up the expiring caches package for more of that. It's kind of helpful. But yeah, that's basically what we're doing in this. So we'll move on to the next step, which is per user. And this is where we have some of the, it gets a little gnarly. So let's see, MacOats resource says method I can't convert object of context handler to an object of handler's handler, line 29. You might just have to resolve or make sure you check out the right branch and hit resolve in your package to make sure it has the right versions of stuff. But yeah, it sounds like it's just maybe a mismatch of some code there. So far as I can see, we don't make use of multiple dispatch. You expand the multiple dispatch mostly comes in handy in numerical code. No, I mean it can be useful. So we do actually use it a little bit in our mapper file. So you can see that we're actually doing like create. Oh no, sorry. That's in the next section. So let me actually check out the next. So I'll say git checkout per user. So here's where we're switching to. We're actually going to make the service per user. So lots of different users can each store their own album collections. What that means is we need an extra table that stores our users now and gives them an ID and they have a username and password. But we use it here, for example, where I have a method for create on an album that will store our album. And then down here, we actually have one for create on a user. And it's just kind of a convenience thing, right? From the service, I can just kind of say mapper.create on stuff. You can imagine having like a generic CRUD service that was like you pass in the type of the object you're saving, and I can just call mapper.create, on with the object type or whatever the object is. So I could create like this generic CRUD CRUD service that created all sorts of different kind of objects, or even like dynamic objects. And that could be useful from a dynamic dispatch perspective. If I had like different type of objects I wanted to store differently, or like a specific object I wanted to overload the dispatch for to map in a certain way. So that would be one thing we could do. But yeah, it's kind of interesting. Yeah, with this kind of layering out, we don't use it a ton, but we do use a little bit. Okay, so we're now looking at per user. This diff is a lot, so I'm trying to think of how we can boil this down to the simplest. So basically what we're adding here, I kind of showed the mapper layer a little bit, where we're now, we have these additional methods where we're saying you can create a user, you can get a user. We added some new endpoints for that, right? Because we need to allow you to, where am I, context handler. So I need you to allow you to create your user, right? So this is kind of like creating an account with a service. And then I need to allow you to log in. So we need some new endpoints here. And those get passed down to the service layer, where we're gonna, again, validate the inputs, pass them down to the mapper layer to create our user. And then when you log in, you're gonna pass in your username and password, and I'm gonna check that the password you passed in matches the password we have persisted in the database. Otherwise, we're gonna throw an unauthenticated error. But then we also want, this is the bulk of what I wanna talk through, is how do we do the authentication? And so we have a new auth module that I've added. We also have a new context module, we'll get to that. But we have a new auth module where we're going to try and handle the authentication in a somewhat automatic way, so that things are secure, but it also doesn't burden our service too much, right? Because we could require that, for every single endpoint, you pass in like your username and password, right? And then every single endpoint, we would like check, okay, username and password, if it matches, and pull it out of the database and make sure it matches. And then, okay, you're authenticated, and so you can do this. So that's like a per request authentication. But that, obviously, that's not very efficient, right? We don't want to be hitting the database that much. We don't want to be having to check authentication all over the place in every single method. And so what we can do is we create a authorized token, okay? So you'll notice that these endpoints here, create user and login user, are wrapped in an authenticate method, which is going to call down to the service. It's going to create a user, or it's going to log in the user. If the login user fails, it's going to throw an error. So we're not worried about the unauthenticated case. In both these cases, we're saying that the user that is returned from these methods, we're going to authenticate them, which means we're going to create a response and we're going to add a token, okay? We're going to create an authorized token to attach to the response that will then get passed back in later, that we can check and know that, hey, this is an authenticated user, and all of the other service methods can know, okay, they're authenticated and we know who it is. So let's look at add token real quick. So we're using the JOTS token, the JWT package. So this is a standard package you can install in Julia. It requires a JW key set. So we've set that up in a resources folder with the authentication keys. This is kind of just a generic set. So this is not, don't use these, please, for your security. This is not secure at all. These are like public on the web. But it uses these authentication keys. It loads them in an initialize step. So once again, we've updated our music albums run. So we need to initialize our authentication. And then we have this add token method. We just saw that. This is how we're going to authenticate and create a token for the user. And we do that using this kind of standard format. We put in our claims in a dictionary. So these are kind of, it's kind of a standard industry practice. You have these claims and you add in some things. So we're adding in specifically our username and our user ID as claims. We're putting an expiration on this as a Unix timestamp from now plus 12 hours. And then we're going to generate our JOT token. And we're going to do that using one of our authentication keys. We're going to sign the JOT token with our authentication key. And then for right now, we're just going to set this as a cookie. Okay, so we're going to have this is our custom cookie name that we made. We're going to put in a set cookie header, and we're going to put our JOT token with the same expires as a cookie. Now, what this means is that most HTTP clients have a way to automatically handle cookies. So they're going to recognize, oh, there's a set cookie header in this response. I'm going to save that. And based on domain, host, and the expiration and everything, if a user calls the same host later on in another request, I'm going to add that cookie. And that's how websites track who you are on the web, right? So Facebook does it. If you go look up, beanbag chairs, and then you go to Facebook, you'll probably see ads for beanbag chairs. How did they do that? Well, when you searched for beanbag chairs in Google, Google said, oh, hey, this is your user, and you looked for beanbag chairs. And then when you went to Facebook, they looked at your cookies and said, oh, you're this user. Oh, you looked at beanbag chairs. We're going to show you ads for beanbag chairs. So this is how web tracking is done. This is why in the EU, they make you on every single website accept cookies. If they have a little pop-up that says you have to accept cookies. It's this, because it's a controversial thing, right? So, but this is one way that we can do session management, is by saying we're going to do a set cookie with a secure token, right? We've signed this token with our authentication key that only we know about. So the user can't deserialize this authentication token. They don't have the key to unsign this payload, this JOT token. Only we have the token. So all they can do is basically pass the token back to us, and then we can deserialize and say, oh yeah, that's one of our tokens that was signed with our authentication key. And then we know that it's this user and this ID. Okay, so that's how we can figure it out. So if we go back to our resource, I'll show you how we've structured this. So we still have our request handler, which takes it in, but we have a new router here. We've set up an additional router. We've set up an authentication middleware, if you will, that is going to route to our create user and our login user. So these endpoints we're saying you can call unauthenticated, but all of our other endpoints are now behind our authentication router. So you have to get past our authentication router before you can get to our, service routes, if you will. So the first thing we do is in the request handler, instead of passing handle to the router, we're passing it to the auth router. The auth router is going to say, if you're one of these endpoints, then you're good. If you're not, then in our auth router, we're passing you to a context handler. So this is kind of a default handler for our router that we can set up. And the context handler, so if you're any other method, right, if you're calling album or whatever, you're going to be passed to a context handler, which is going to try and set a context, okay? So let's look at that a little bit. Context module, really quick. It's pretty simple. We just have a context object, and then we're creating a with context method, which is kind of a do block function style. So you pass it a function to call. And what it's going to do is it's going to set, you pass it a user, it's going to set context in task local storage. And then we provide a getter method, which means you can call context.getUser, and it's going to say, hey, is there context set? If not, then there's no throw an error, there's no valid context. And it's going to pull the user out of our context, okay? So this is a way that later on in our mapper file, when I'm getting an album ID, notice that I'm still just passing in the album ID, but I can also pull the user out of the context, Okay, so I can see who is the current user in the context, and I can pass that because now we've changed our database table. It's no longer per album ID per song. We're now per album ID, per user ID, per song. Okay, so we've added an extra layer here so that we can have a whole table of albums that are also per user. So we know which albums are for which user. Okay, and in the get, that's what we're adding here. We're saying select all from album where ID equals album ID, but also and user ID equals the user.id. Okay, and we pulled the user out of our context. Okay. So let's talk about how we set the context. So back to our resource, we have this context handler. I know I'm going fast, sorry for that. If you call one of our non-authenticating routes, then you get past the context handler. So if you try and call get album, then you get past here first. And then we're gonna try and call user on the request. It's a little bit funny, maybe I shouldn't have called that, but we actually are defining the user method on the request in our auth module, okay? And so what that means is I'm trying to create a user object, okay? This is a new model object here, okay? This is a struct and it's got struct IDs, it's got a struct type and everything. So this is a new model object, it's a user, has a username and password. I'm trying to construct one from a request, okay? And how we're gonna do that is the inverse of what we did with add token. So in add token, we set the cookie, we created this authenticated token and we passed it along. And now we're gonna pull that out of the request. So we're saying that, hey, I expect the client to have passed back that cookie, okay? So I'm first checking, hey, do you have a cookie header? If you have a cookie header, do you have the right cookie header, right? Because I want to make sure that you have the cookie header that we set. We named our cookie X musical albums jot token, okay? Make sure you have that, okay? If it's not empty and it has a value, then I'm going to create a jot token with that cookie value. Now, that's not enough. I can't just stop there and say, okay, that's the token and move along, because what if they're trying to spoof us? What if they're trying to randomly generate a jot token that looks like a jot token, but they generated themselves? I need to know that it's authenticated. So I say, let's assume it's verified false. We're gonna loop through our authentication keys. I might have multiple, okay, if I'm rotating them every so often. And I wanna make sure I can validate that jot token with one of my keys, okay? So you've given me a jot token. I need to make sure that it was signed with one of my keys. And if so, then I will mark this jot token as verified. If it is verified, then I can trust the parts, the claims of the jot token. I can pull, remember we stored the username as AUD and we stored the user ID as UID as part of our jot token claims. So I'm gonna pull those out of the jot token to create my user. So that's how I create a user from an HTTP request, is I'm verifying the token that was passed in. And so this is a nice way that in my context handler, I'm saying, if you're in the context handler, I'm assuming you are a valid user. I'm going to get the user out of the request. I'm going to pass it to with context, which is going to set context for a specific user, okay? And then I'm going to http.handle on my router. So this previously lived, way further down, right? We weren't authenticating, we weren't doing all this other stuff, but now it's moved a couple layers up our middleware stack. So where now we are first checking if you're authenticated or not, or if we need to authenticate you, we're setting context, we're doing all these things, and then we're getting to our original handlers. So that's how we can authenticate users. That's how in the mapper definition, we can pull a user out and know that they're valid and know what context we're in, right? And in the service layer, we actually I don't even think we even need to use the context module, because we're not worried who you are in the service layer. We are only, concerned with the business logic. It's only in the mapper layer that okay, who are you? And I need to make sure I have the right context for storing things. So I think, sorry, that was fast. I think that's everything we wanted to talk through on that. So let's talk through concurrency real quick, and then we'll talk through deployment. So if we check out concurrency here, concur, let's check out our diff here for what changed in concurrency. So the idea here is that now that we're allowing multiple users to use our service, right? So I could have 100 people all calling my service at the same time. I'm a little bit more concerned about concurrency, right? I'm gonna have people from all over the world all trying to manage their music albums at the same time. So I wanna make sure my service is utilizing concurrency to make sure that it's not one user request at a time. Remember, we are getting a little bit concerned because HTTP server at its base is doing green threaded management there. But I wanna make sure if I'm on a service box and I have multiple threads available, that I could use those if I want. And I want to talk through, mapper concurrency as well. So we've added a quick workers module. And what this defines is a way to spawn threaded tasks. So a task is handled by another thread that's not the main thread, okay? Because that's a tricky bit with working with a microservice, right? Up till now, our HTTP server is running on thread 1, and all the requests, everything that gets handled is all on the same thread, all the way down to the mapper layer. It's all on the same thread, which that's not great, right? Because what if I have a super expensive, in my service layer, if I pick an album, I'm trying to pick an album to listen to, and somebody's got, 1 million albums, that might be a really expensive. It might take several seconds. And while I'm doing that, that's tying up thread 1, okay? So that it's actually stopping the HTTP server from handling other requests, unless there's task switches going on in your service layer, which typically there won't be. So we wanna make sure that we're concurrent and that we're not bogging down thread 1. And so we're gonna add a way in our workers module. We're gonna make a macro async. So it's kind of similar to like asyncing a task, right? But this is a workers.async, which is going to spawn the task on a non-thread. And how we do that is we have an init. And basically what we're doing is we're looping through each thread available. Okay, so each thread available, and we're going to start an asynchronous task on each of those that will just pull tasks from a shared work queue. Okay, so up here, we're defining an unbuffered channel of tasks, which is a work queue, and then each thread has its own task running that is trying to pull tasks off that work queue, off that shared work queue. Once it pulls a task off the work queue, it schedules it. So it's going to do it, and then it's going to wait for it to finish. Okay, so each thread will be working on one task at a time, but it's going to pull it off. Once it's done, it will check the work queue for more tasks. It's an unbuffered channel, which means that if we try to put another task on and there's nobody ready to take the task, then putting will block, okay? So this is kind of what we want in our microservice architecture. It'll put, but it's also not blocking our HTTP server. So the main thread 1 will be our putter, right? It's going to get requests in and then decide to put tasks onto our work queue. And then we'll have worker threads that are all trying to pull tasks off the work queue. So this is a simple way that we can kind of get this background task, service workers doing stuff in the background kind of thing without bogging down our main HTTP task. So let's see where we use that. We only have one call that should really be expensive at all, right? All of our others are pretty straightforward. They're just dealing with like one album or one user, updating like one database call. So we're not really worried about a lot of those. We're going to let our main HTTP thread 1 handle all of those. But this is the main service call where we're a little worried that things might get expensive. If people give a lot of albums, if they've just loaded like 1 million albums and none of them been ticked, none of them have been picked, then we're going to be dealing with all of those. It might be lots of memory, it might be lots of computation time. So how could we do that one method on a background task? Well, let's go up here. Actually, let's go look back at our diff. Then we can look at our resource file. No, we don't want to talk about connection pools yet. We want to talk about, okay, so we did do workers init in our run, but here's the magic, okay? So pick album to listen to in our resource file. Instead of just calling directly to the service layer, we're now saying, hey, workers.async, you take care of picking the album to listen to, and then we're gonna fetch the result of that. So fetch is good because fetch is happening on thread 1, but it's non-blocking. It's gonna wait and task switch until the background thread is done doing the work. And then it's going to return to thread 1, which then we're fast, right? Because then we're just serializing the response and sending it back to the client. So here we've automatically made this one service call asynchronous. It's running on a background thread. We could handle a bunch of these, and they're all going to be done on different background threads. And then the thread 1 is still only in charge of the main middleware stack and then returning the response. That's all it has to do. So that's kind of how we set up the concurrency there. Let's talk really quickly about connection pools. I know we're running out of time, so we'll just go through this really quickly. I'm gonna package this up in a separate package. I think it's pretty much ready to go, but this is a way to pool connections. So it can be useful in a lot of different cases, databases, HTTP connections, that kind of stuff. Here we're using it to, because the motivation here is, right, now we're asynchronously handling that pick album call. And we're also allowing multiple users to all be calling in at the same time. We don't want our mapper layer to be the bottleneck, right? Because right now it's doing like one database call at a time. And if if you're making a call on a database, oftentimes that will lock the database while you're doing it, or at least lock the connection that you're doing it on. You can't make simultaneous queries on the same connection. So what we want to do is have a pool of connections that the different mapper calls can pull from to execute their queries. So we make a DB pool using a connection pools pod. So a pod is like a specific keyed pool. And we're going to initialize that pod in our init function, okay? We pass it a function so it knows how to create a new connection. So in this case, it's pretty simple. We just say SQLite DB with our DB file. That might be passing it a host or something if it was a database that was remote or something, password, all that config. We have a couple different options here in terms of how many different concurrent requests we want to allow, how long we want them to last for a connection. So if it's older than 60 seconds, it's going to expire and we'll throw it away. And then how many, I can't remember where this one is, but there's a couple of different configuration options for the pool there. But then we're going to consolidate all of our mapper calls to call one execute function here. So we're going to pass in the SQL, any params, if you're doing an execute many, and then we're going to call this with connection, which takes a pool. And what it does is it will do the thread safe dance of acquire and release of a connection and pass us a valid database connection, okay? So with connection from our pool, it'll give us a database connection. We can then use it like we were before. We can prepare the statement. If it's execute many, we'll do execute many. If it's not, we just do a regular execute. And then that returns whatever the result is of execute many or execute. And then at the end of with connection, it's going to release the connection back to the pool so that somebody else can use it. But this is our thread safe connection pools. Like I said, I'll package this up in a package so that people can use it, but it's really handy. I think that's all we want to talk about there. Let's check the Q&A real quick. Can the router also route relative to parent routers, or are paths always from the root? Good question. I think it's always relative to the root now. We should look into making that possible though, like allowing it to route relative to the parent router. That'd be a good addition. Next one. So are all the non-made threads are busy waiting? Yes. So if they don't have a task they're operating on, they will basically block on, if we go back to the workers, they're going to block on this right here. So this is kind of a clever thing you can do with channels, is you can iterate a channel, which means on an unbuffered channel, then it will, if there's no tasks in the channel, it'll wait until a task is available, and then it'll take it. So the channel basically builds up like, here's all my waiters. As soon as I get a task, I'll give it to the first waiter. And then if you're the next waiter in line, it'll bump you up. So yes, those background threads will basically be blocked waiting for the next task to come in. And then like I said, if all the threads are busy, if you get really saturated, then the main thread will block on putting to the unbuffered channel, which is good because that's a, it blocks and then task switches away to something else until, until there's a thread ready to take it, then it'll switch back and put it. So yeah, it works really well to use an unbuffered channel there with the iteration and the put. Would it work if the route function uses threads that spawn to handle expensive calls rather than using the custom async? Yes, using threads.spawn would work, but just be aware that threads.spawn might spawn your task on thread 1, which is where your HTTP server is working. So it could, if you happen to spawn on thread 1, that could bog down your HTTP server. So then your server might not seem responsive. You'd be like, whoa, my server froze. It's not responding to requests until it finished that expensive call. So that's why we're using the workers setup. Is to ensure that those tasks only get handled by background threads, not thread 1. Okay, 6 minutes left. Let's go.
Now we're scheduled to 1:30 for another half hour.
Oh, we do. Oh, that's great. Okay, so we have a little bit more time. All right. So let's talk about deploying. Definitely feel free to ask more questions if I'm going too fast or if you have other stuff, or I'm always available on Slack, or if you want to open issues on different packages or wherever, discourse, happy to talk more later. Let's talk through, well, let's see. So did we finish that? We're feeling good about concurrency. Yeah, I think we are. We're feeling pretty good. So connection pools, basically we turned our only request that we were worried about being expensive into an asynchronous, so it'll be handled on a background thread. We do have to make sure we start Julia with multiple threads, or that won't really make a difference, right? So we need to start Julia with multiple threads. And then the only other thing we were worried about concurrency wise was with our mapper definition. So interacting with the database, that's where we're using connection pools. So it's going to spin up a pool where we can have up to, however many connections at a time. You'll notice that I configured the pool to have threads.endthreads because, and we could actually do end.threads. Yeah, no, we would want to do that because that ensures that there's basically a connection per thread that we can be using at any given time, which is the most that we would expect, right? Because, or realistically, because as the requests come in, each thread is pretty much handling one request all the way down to the mapper and back. And so we'd only be expecting, end threads number of connections to be needed at any given time. If they happen to be doing like more concurrency than that, then we probably want them to be waiting anyway until one of the connections is released, and then they can go get that freed one. So that's kind of why we chose the end threads there, is because we want up to end threads number of SQLite database connections available that the threads can pull from. They can use it, execute their queries, and then they release it back to the pool. So yeah, that's connection pools. And yeah, you'll have to look through the code to see how we kind of synchronized everything down to the one execute method. But we wanted to use the with connection to, I will say that sometimes it's even easier, like sometimes we'll separate our mapper layer from like a a device layer, right? So we might have like our own SQLite wrapper module where we managed, the connection pool and configuration of that. And maybe we want to abstract, separate the mapper layer from the database we're using, so that maybe we want to swap databases layer to like MySQL or Postgres or something, so that we would just swap out the device that we're using as opposed to needing to rewrite lots of the mapper layer. So we could abstract the mapper layer, and it's pretty well abstracted, but anyway, I digress. So let's talk about deploying real quick. I'm going to walk through how we could bundle this up in a Docker image and deploy on Google Cloud Run. So if we look at the diff here for deploy, we have a Docker file. Sorry, let me take a drink. So in our Docker file, if you're not familiar with Docker files, go look it up. But basically, you start from a base image. We're starting from the official Julia 1.5 RC1 image. And then the main piece is we add in all of the code in the current directory. So that's what add dot means. So we're adding it into the Docker container. For those who don't know, Docker container is basically like a little Linux VM that you can run stuff in a predictable way. So we're taking code from our local machine and putting it into the Docker container with this add.home. And then for the entry point, the important part is we're running Julia, and then -e means run this code, musicalbums.run, and we're passing it a SQLite database file and our authentication keys from our resources. So we need to pass those in as config. We could hard code those, but whatever. We want those configurable probably in case we need to switch them out. Now, the thing I did forget on this, I realized, is to actually add multiple threads. So I think by default, this is actually only running Julia with one thread. So all of our concurrency thing isn't working, but that'd be easy to change. We just need to change the entry point here to say Julia num threads, like -t8 or whatever, how many of our threads. Now, the other stuff that's in this Docker file here is we are adding the GCC compiler. We need that because we're also running package compiler, okay? So we're running this command here, Julia deploy package compile, because that provides us a way, oh, there's our manifest file, big ugly guy. So we added package compiler to our project toml. So he's a dependency here, so we can use him. So here we're saying package instantiate, use package compiler. We're going to create a system image for the music albums module. Here's what you should call the system image. And we want to run through some code to precompile into the system image to make things really fast, okay? Now, one more layer. What's our deploy precompile file? So what are we running? What do we want to run that gets precompiled into our system image? Well, we're just going to cheat and run our tests, right? Because we already set up our run tests to use our client, and it starts a server in the same process, and it hits all of our endpoints. And so we're basically executing all of our code paths. So that's great, really easy. So basically, it's going to load our music albums, run our tests, save all the code that gets compiled while running all of that stuff, save it in a music albums.shared library. Okay, that's what we need GCC for, is creating an actual shared library. And then remember in our Docker file, we had an additional point to our entry point, which was -j musicalbums.so. That means, hey, don't use the base Julia system image. We're going to use this custom system image, which means when I start Julia, you notice that I didn't say using music albums. It's already there. It's already loaded, right? Because it's already built into our system image now. I just say musicalbums.run, and boom, it's going to start up right away. All the methods are already compiled. I could hit it with a client immediately and there'd be no lag on the server side. So that's how we're using package compiler, doing some magic there. I also added in an extra piece here. So remember earlier when we were doing authentication, I said we did this set cookie thing. We're also just going to set a header with our token because it turns out, I found out last night, Google Cloud Run strips all the cookies out when it's going in and out of their service where we're going to deploy our service. And so it kind of wipes away our cookie. So the client gets confused. It's like, wait, I don't have any cookie. And then the server's like, well, you're unauthenticated. I don't know who you are. So an alternative is we can also just set a header with our authentication token that we're generating. And then when we're checking the authentication, we still check right here if they have the cookie. If they have the cookie, we'll use that. But then we're also adding a path where we'll say, hey, if you have that header that we set, then we're also going to check that to see if it's a valid token. And that's where, let's see, we should have a change in the client file where we're also passing in so we're saving that token here. So we created a ref for the auth token. So when you call create user or login user, it's going to set that it's going to send that token back in a header. So we're going to save that. And then for other endpoints, when I try and create an album, I'm going to pass that token in that we saved from login. So it's a little bit more work on the client side. It's kind of annoying, right? It's not as automatic as cookie management, but sometimes if you're dealing with a service like Google Cloud Run that's aggressive about stripping cookies out, then that's an option that we might have to use. We might have to enhance our client wrapper to pass the token in so that the service can still say, oh, yeah, okay, you're authenticated. I know who you are. You've got a token that I recognize, okay? As long as the client and the service can talk to each other. And remember, like this client is written in Julia, but the client could be written in any language. We could create a Go client. We could create a JavaScript Node client. A lot of the times you will have a JavaScript client because if you're writing like a web page, then you need, in your web page JavaScript, you need a client that could talk to your microservice backend, right? And so it would run. This would all be JavaScript. You can do all the same stuff in JavaScript. We would need to check for that auth token and send it back with the other methods, that kind of stuff. So anyway, just to say that this client stuff isn't Julia specific. But yeah, so once we have that built, then in our, let's go to, so we have our music albums. We're pretty much at master now. And so you see we have our Docker file. We had a manifest in there. We don't actually need that. You can instantiate without it, but I was fixing some bugs that I ran into. But now we're ready to deploy, okay? We have our package compiler stuff. We have our Docker file. So we could build the Docker file locally, okay? We could go to the command line and say Docker build dot and give it a tag, and we could build that Docker container locally, but or we could build it somewhere and like share the Docker image. We could put it on Docker Hub in a private, Docker Hub repo and share that with other people. They could run it themselves. But we want to actually deploy ours in Google Cloud Run. I'm going to show us how we do that. And so I already have a project set up. So to answer the anonymous attendee question here, do you prefer Google Cloud? I'm going to show Google Cloud today because I already have a Google Cloud project set up, and I played around with AWS. You could definitely use that as well. They have some great serverless Lambda stuff, or Fargate is another way you can just kind of throw a Docker container out there to run. I like Google Cloud Run because it's you can give it a Docker image and it'll set up a public URL for you and just run it. It'll just run your Docker container and you can configure how it auto scales and stuff. So it's just really convenient when you want to run just a single Docker container. And then you can also easily switch over to the Google Cloud Run with Anthos if you want to do several microservices that all talk to each other. So they could be kind of within their own little bubble and talk to each other, and it's all authenticated and everything. And you can still get a public URL and stuff. So I think Google Cloud Run is really cool. You also only pay for the requests that come in. So it's serverless in that way. You only pay for what you use. It's just really convenient that way. I think Azure also has a way to just kind of throw a Docker container out there and run it. I haven't looked into it as much, but yeah, there's lots of cloud options here for deploying a Docker container kind of thing. But I like, yeah, as I said, I'm kind of most familiar with Google Cloud Run, so that's going to be a show today. But the idea is that we can actually,
Hey, Jacob, could you zoom
Jacob,
in?
could you zoom in?
oh yeah, yep, good point. So it's really easy. You go to Google Cloud Build once you have your project set up. So this is, so I actually built my wife's, she's a photographer, and I built her website, using all of this stuff. So that's the project I already have set up, but I am using that to deploy this real quick. But it's really easy. You go in here, you can say connect repository. You say, oh, it's a GitHub or a Bitbucket or wherever it's from. You click through, you authenticate, and you select your repository. So here's all this stuff that I have access to. So I already did that, and I set up the build for this music albums. You can set it up to automatically build when you make a new release or when you push any change or anything like that. Super cool. So then I actually kicked off a build already. So oh, that one failed. Oh, build, why did you fail? Dun, dun, dun. Keyword expecting nothing, substring string. Oh, okay. That should have been fixed. Okay. Well, it looks like my build didn't work. But as you make new releases, so I set it up to make a new build anytime I make new release. So I made a couple releases. I was testing this out last night, and it was building them. And then what you can do is, so we start in Google Cloud Build because this is who's building our Docker image. Okay, so if we actually look into this build, like that's the logs I was looking at, is it's actually building, it's running through the Docker image build steps. So Docker image, sending build to context, and this is step 1 of 9 from Julia. So that's exactly what we had in our Docker container, in our Docker file. Oh yeah, I'm not on the right branch. Okay, git, I'm just gonna do git checkout master because it's basically the same thing. So that was our Docker compile, is this from command. So we're going to see it run through each of those steps. And then it gets down here, it installs GCC, and then it instantiates all our packages. And then here it's, this is where it's trying to do package compiler, and it's trying to run through the code. Oh, I think it's because it's trying to hit the Google server instead of, yeah, so right now it's set up to hit the Google server instead of localhost. So if we change this to localhost 8080 again, I was testing out running the client against the actual server I had deployed. So if we change that and we git commit that, git commit fix client host, and we push that, and then we go to our repo and we can make a new release. Okay, we're going to draft a new release, and this will be v.1.7, v.0.1.7. We're going to make this release. Okay, so I made the release. If we go back to build details, then I'll see that'll kick off a new build history. Okay, so boom, it's already running. This is my new tag. So this is kind of, Travis CI-ish, right? So this is Google Cloud Build, and it's going to build, and you can see that with a successful build, it produces build artifacts. So it actually created an image for us here. So it saved the image in, this is part of the Google Cloud thing, this container registry. It saved these images, and I can actually click into here and say, okay, Quinn J, GitHub, musical albums, here's the images that you have successfully built. Okay, so that's pretty neat. So it's basically hosting the Docker images for us that get built. And then when I go down to Google Cloud Run, it's really easy to create a new service. Okay, so I can create a new service, and it says, okay, what region do you want to run it in? Do you want to do Anthos, which means, you know, you're kind of creating this little bubble that you run all your services in. Create a name. So I said, you know, music albums. And then here for the authentication, I can say allow unauthenticated invocations. Check this if you're creating a public API website. So I want to let anyone basically hit my endpoints that I'll be serving in my Docker container, which is what we want, because we're doing, remember, we're doing our own authentication within the app to make sure, you know, people don't get crazy. With this one, you have to say only people with, you know, whatever Google Cloud permissions can hit your endpoint. So I'm going to say allow unauthenticated, and then I just say, it says, okay, pick your container image. So I can say select, I go over here, I can drill down to the image I just created, okay? I select that, and then I can do some advanced settings where I can say, oh, my server's actually listening on a different port. That's kind of why I chose 8080 in the beginning. So, because that's the default Google Cloud Run. Oh, it's scrolling, wow. You can give it a custom command, arguments. We just want to use our default entry point, okay? You can choose how much memory gets allocated to your thing. So like I mentioned before, the Julia runtime uses a couple hundred megabytes. So we at least want to bump this up to about 512 by default. But if you know you're going to be doing crazier stuff, you might want to go up to a gig. Remember, you're only charged for how much is used. So allocating more isn't going to hurt you. It just means you're upping the upper limit of how much can be used. And then we can also set stuff like the request timeout. So what's going to happen when Google deploys this for us is it's going to take our Docker image and it's going to wrap it in its own kind of front load balancer, right? So it's going to do a little bit of management of the incoming requests for us. That's why it can do the authenticated thing or whatnot. And it's also why it can do this request timeout. So it says, hey, if the service takes longer than 300 seconds to respond, then we're just gonna, you know, bail on the request and say, you know, server timed out back to the client. You can also control how many requests per container. What's the maximum number of concurrent requests that get handled. And then we can also control the auto scaling. So how many instances of my container, right? Because once they get up to 80 requests being served by your container at a given time, they're going to deploy another instance of your Docker container, your Docker image, okay? And this is how many instances of your Docker container you want to scale up to. So probably don't want 1,000 if things like got really crazy and someone was DDoSing you. So maybe you just want to go up to like 5 or something, but you can control that and edit it later. But this is how we can set up a service really quickly. Once we do that, then it deploys and it generates a URL for you. And if you already have your own domain, then you can manage your own custom domains. So I own, for example, sarahquinnphoto.com, and I've mapped that to my Sarah Quinn photo service that I have set up already. So this service is running, and when you go to sarahquinnphoto.com, it's rerouting you to this URL that they auto-generated, which is gibberish whatever run.app, to where the server is actually running and responding to that. Okay, so that's how we can easily deploy our service. We get our URL. We could share this with people. We could also like I said, use a custom domain and map that right in here. So it makes it really convenient. Let's check on our build real quick and see if that finished. Let's see, back to Google Cloud Build. Oh, so it looks like that's still running. The package compiler step tends to take a little while just because I don't know exactly what it's doing, but it's having to actually compile a big shared object. So while we're waiting on that, we'll finish by seeing if we can actually hit our live running service from our client. But let's do a couple. Oh, I've been answering this question all along. Sorry, Anonymous Otandi. That was a very long-winded answer to whether I prefer Google Cloud. Yes, just because I use it, but not necessarily. I mean, I think all the options are good out there. So thanks, great workshop. Any resource experience on how to deploy any Singularity containers for HPC clusters? For HPC clusters, it's just, I feel like those tend to be very customized anyway. So it's really just depends on how they have it set up. I think the world in general is moving towards, Docker as kind of a standard, just because it's easy to make a Docker file and bundle it up, and you could build it anywhere or build the image and then share the image. So that's why I kind of showed that in the workshop, is because it's kind of becoming a very standard thing. It's how we deploy, stuff at Domo for microservices and stuff. It's just a really convenient way to kind of define the steps of your build and then make that portable in a lot of different places. And then you only need Docker to like run that somewhere. So anyway, for HPC clusters,
most Docker files can be built into Singularity containers. It gets a little bit nuanced with like user permissions, but otherwise something like this would just build to Singularity, no problem.
Okay, cool. Yeah, thanks for chiming in on that. I guess I actually don't understand what a Singularity container is necessarily. So thanks for jumping in, because I was not being very helpful there. So it looks like the build finished. So if we switch back to our thing, we can edit and deploy a new revision. We go here and we say, oh, I actually just want to switch the image out. I'm going to go drill into my images. If I hide this for you, looks like this is the image that was built just now. So I'm going to select that. And then I go down here and say deploy, and it's going to spin up a new instance of my container. And then as you can see, all the traffic right now is being routed to the older container. But as soon as this is deployed and ready, it's going to reroute the traffic to my new instance. And then we're going to get ready here, because we're going to copy the URL here. We're going to go into our client. And I guess we don't actually need to change it there. We're going to go to Julia, and we're going to restart. We're going to say music albums. And we're going to say client.server equals this. Oops, I need quotes around that. Okay, so now the client server is set. And so now we're set up. We could actually run through some of those commands we've seen before. If we called, for example, create, no, first we gotta create our user and log in, okay? So we're gonna first create our user once that switches over. Okay, it looks like that switched over, that deployed. So I'm gonna call create a user with my password, Julia Forever. And so the slowness here, remember we said, oh, we use Apache compiler, it's gonna be so fast. But remember, I'm still running the client locally in a non-precompiled place. So the only compilation happening here is on the client side. The server is all precompiled. So it's just the client side that has to compile all the HTTP methods and everything, and the JSON3 deserializing. It's got to compile those methods. So that's the lag that we're seeing there. So that worked to create our user. And I had this method in here earlier so we could show if we got a cookie back. But as you can see, Google Cloud is stripping out the cookies. So we're not getting any cookies back. But we did get our authentication token. So if I look at my authentication token, look, we got our authentication token back. So hopefully now if we run another endpoint like create album, this will work. Yeah, it worked. Okay, so we are hitting our live deployed microservice, and we can create albums, and that's specific to me as a user. It looks like I'm user 2 here, and I created album number 1, Now, two things that, yeah, I realized didn't get put into the final code that I'll update is, remember that in our Docker file, we're actually not using our concurrency. So we need to add an option here where we say -t, we could just say 2 for now. Oh wait, I think we need, for Docker, I think we need to do like this. So we need to do -2t, which then in our deployment, we would want to go in and edit to say, hey, I actually want to have 2 CPUs allocated. So I have 2 cores that I could, and I'm going to start 2 threads, have 2 cores, and I'm going to have a true concurrent service here. The other thing I was going to mention is I was reading through some of the Google Cloud Run docs, and they actually explicitly say that, and I wasn't sure on this because they have you deploy a Docker container, but they don't call it out as like serverless explicitly very well. So, but reading through the docs, it is more serverless than it is serverful. So they will deploy your container, but they don't guarantee that the same container instance will be deployed all the time. I wasn't sure if they just deallocated resources from your container or if they actually spun it down and then spun it back up. But from the docs, they actually say that they spin it down and spin it back up. So like in between requests, they might spin your container down, and then when a request comes down, they might spin it back up real quick. So that's bad for us, right? Because remember how we're doing our mapper. We did configure it so that the SQLite file you had to pass in as a file, but we're just passing it in as like a file within the Docker container. And so when that gets spun down, we're basically losing our SQLite database. And that's not going to get persisted necessarily from request to request. So it might be the case that if I came back later today and I tried to call get album on the ID, that this would throw an error, because it would be like, whoa, I don't know what you're talking about, because it may have destroyed the container in the meantime. Right now, it's still got our container up because it's getting requests, but that might not be the case. So if we wanted to do this more properly, we would probably deploy our SQLite database as its own service. So we would create an own service just for our database that would have a Docker file. There's probably a standard SQLite database Docker file we could set up. It would run as its own service. And then in our service, in our microservice we built up, instead of passing the database file, we could pass it like the URL to say, go get the current version of the SQLite database, or go get this remote database, or connect to it. Or the other option is we could switch to a different database entirely. So if it was a MySQL database, we could run that as our own MySQL service, and then we would set that up in our microservice to hit that. So hopefully that makes sense. I realized that how we set it up, I thought we would be okay with the SQLite service as is, but if you were doing this properly, you would want the database to be hosted separately anyway. I mean, you probably would if you're running in like any kind of production instance anyway, but just so you know. Okay, I think we have time for a couple more questions. The two are completely different, whether it depends on use case. Kubernetes is a lot after all. Yeah. Oh, is Docker, oh, sorry, I was reading the response. Is Docker preferred to Kubernetes for this use case? Yeah, so like Jorah said, they're pretty different beasts. So Kubernetes is more like when we went to deploy, there was like the Google Cloud Run with Anthos, right? It's more like the Google Cloud Run for Anthos, where you're kind of creating an entire bubble that you have several microservices all running in, and they can talk to each other. And Kubernetes is trying to make the talking to each other really seamless. So you basically can talk to another microservice just by the microservice name, and Kubernetes is handling all that routing for you. So if you have lots of microservices, deploying them all together, Kubernetes can be a good option, but you're still deploying each microservice using Docker. So at its core, Kubernetes is still deploying pods, which use Docker images to deploy those pods. So yeah, they're kind of different beasts, different parts of the layers. A lot of the times Kubernetes can be overkill if you have, even if you just have a couple microservices, you'd probably get away with running something smaller that just managed the few. Just because Kubernetes introduces a lot of concepts and not necessarily overhead, but just conceptual overhead. But yeah, anyway, that's kind of my take on that. Any thoughts on logging inside the Docker container? Yeah, so we can actually see here that we have logs for our running thing. So if I go here, I can look at the logs for my Docker container and see, oh, okay, we set up some logging here. And I didn't really walk through this in very much detail because we kind of brushed over that. But we added some logging in where we said, oh, I want to know when a service request starts, and then where service requests end. We're seeing the duration of those. We're seeing how big the body was that gets sent back. We're seeing when things get deleted or or whatever. So we can see the logs here. Now, I was going to have this whole spiel about logging, and I guess I'll finish with that. Is the logging built into base is very much meant for more like interactive scripts, but it's not super convenient for like running production apps, right? Where I want a lot of more control over the log format, or I want to do maybe distributed on multiple processes. Base logging doesn't really account for that at all. Even with threaded logging, it gets a little weird. So I'd say you're much better off using just making your own custom logger. So the nice thing is that base makes loggers easy to like customize your own. So you just make your own custom logger that subtypes, I think, abstract logger, and then you define your couple logging interface methods, and then you're off to the races, and you can kind of define that. The other thing is, like, I wish the base logging was a little bit more configurable, because once you start making your own custom logger and do all of that, like it's like not really that much different from just making your own logger yourself. So like I can show you real quickly, like in our Domo code, we actually have, I just made our own logger ourselves. So it's a logger. It doesn't subtype the base logger, but it's thread safe. And I define my own macros, so it just calls in with the level, and we get some. We like to log for every single log line, like what the module is and the source file and the line, so that we know where things are coming from, like stack trace wise. We also want to do the custom error handling, and so this isn't a ton of code, and this isn't much different from making your own custom logger anyway, but this is actually my own custom logger. Like I'm just print lining the message to the output. We also want to do like JSON output, so we do that. So that's kind of how we did it. Like I don't think the logging is super hard to just kind of roll your own. I will put a plug out there for 2 logging packages. Memento is really great. Built by NVIDIA folks. I know there's been a lot of thought that goes in. They do really good like hierarchy stuff when you need to do like hierarchical filtering and stuff like that. And then also, I think Linden has a package called Logging Extras, which also has some cool composable logging tools that you can use. So I would look into those probably first before I rolled my own if I were to do it again. But like I said, rolling your own also isn't super hard, and it can give you exactly what you want. But that's just to say that base logging is kind of restrictive, and it feels a little constrained. And I think it'll get there. I think there's been enough open issues and stuff where we're seriously, like there's been serious discussions around how do we kind of rebuild base logging so it does more what everybody needs and wants. And so I think maybe in a Julia 2.0, we don't need to roll our own loggers as much, but for now, that's kind of the state of things as far as I see. Okay, so I think I'm 2 minutes over. I don't know if we have any more questions. It doesn't look like so there, but I think that's, oh, we have one more question come in. asked about HTTP versus HTTP. If I understand code, code use case transmits album data that's not encrypted. What if you didn't want anybody snooping at your internet trying to see what music you're listening to? So when we switched over to the client, you'll notice that this client server is HTTPS. So Google is actually fronting HTTPS for us when we deployed on Google Cloud Run, which was nice. Like, and that's what I said earlier is it's kind of nice when you can just have kind of a front gatekeeper server to handle the HTTPS for you. Like I didn't have to deal with any certs or SSL certs or anything like that. Let's encrypt. I didn't have to do any of that myself, which was a really nice thing about using some of these cloud managed services is they'll kind of manage that part for you and they just generate the URL for you. So that's really nice. So it is encrypting our requests going over and back. If I wanted to do additional encryption on top of that, then I would have to manage that probably in my client and server configurations, right? So if I wanted to base in 64 code everything or like sign it with my own whatever client key, auth key, something, we could do, you know, some kind of additional authentication dance between the client and the server, but I would need to do that in the code and manage that. So hopefully that helps answer that. So yeah, thanks
Thank
everybody.
You so much.
I'm gonna probably spin the service down so that people don't just like hit it and charge me a bunch of money. But if you want to play around with it, feel free. I'll leave it up for like an hour or two. I don't mind, you know, doing that for a little bit. But yeah, anyways, thanks everybody for listening. And yeah, I enjoyed it.
Thanks, Jacob. Thanks everyone for joining. Please join for the rest of the week and check us out on Slack and Discord and live.juliacon.org or .com. I think it's .com. Thanks all. Bye.